Dear friends, welcome to PROFES2020. This is the 21st edition. I'm very excited to open this conference. Unfortunately, I cannot see you in front of me and you cannot see me in front of you. That's it. That's how it goes this year. Anyway, we have a great program. We have great papers, great presentations. So I'm sure we will have a great conference. Actually, after me, the program chairs will tell you about the program in more detail. We have decided to trim the presentations to half, actually, to 10 minutes each, so that everything is executed in 4 hours in the middle of the day. So hopefully all of you anywhere in the world, independent of the time zone, can watch live the conference. We have also tried to find tools to support interaction as much as possible. So I strongly suggest, I strongly push you to make questions to make the conference as lively as possible. I would like now to thank all the people who made this possible. So first of all of you who are watching, thanks a lot. Thanks to the people who wrote the papers, thanks to the authors, thanks to the presenters. I would like to give a special thank to the team who is supporting this cyber conference. On the stage, on the backstage actually, we have Simona Leonardi, Maria Chiara Meccati, Riccardo Coppola. They are doing a great job, and actually, guys, it's in your hands, all the success of this cyber conference. Thanks again. Finally, don't forget that next year the conference is in Turin, in real, I hope. So please come next year. And so a big hug, a very big hug from Turin. Enjoy the conference. And now I can leave the stage to Andreas and Marco, the program chairs, who will tell you more about the program. Thanks.
Yes, thank you very much, Maurizio, for the warm welcome. And I would also like to express my warm welcome to the audience, wherever you are. My name is Andreas Setlichka, and on behalf of the PROFES Steering Committee, as well as my role as a program co-chair, I would like to welcome you to the 21st edition of PROFES. Unfortunately, we are not able to enjoy the nice city of Torino, as Maurizio already told you this year, but hopefully next year we will meet there. Nevertheless, we are glad that the organizing team around Maurizio and Marco found a way to make PROFES20 happen, and we will give them a warm applause, even if it's virtually. So thank you very much for the whole team. Then also to you as the audience, I'm very happy that we have you here and that we could attract so many people to submit to PROFES and also to attend the sessions now. So next slide, please. So as a living community, we probably also have some new people here who do not know PROFES. So let me give a very short overview of who we are, what we are. So PROFES was founded as a result of a large European project with the same name. The project took place somewhere in between 1996 and 1999. And the first edition took actually place in Oulu, which is in the far north of Finland. With the 5th edition in 2004 in Japan, PROFES also went out of Europe, became more international. Also, we are still, let's say, from the home base, an European conference, but with many people also from Brazil, from Japan, and from all over the world, which is also expressed in our program committee. We still believe that there's a relationship between the process and the products to be developed. However, we saw several topics coming and going, others growing, like, for example, Agile, Scrum, or nowadays artificial intelligence. So as a conference, PROFES wants to bring together research and practice, encourage and facilitate exchange between them so that both can benefit from their attending PROFES. If you have a look at the PROFES community, We will find several very experienced people like myself, Maurizio, so you can also say the older ones, but you will also find lots of younger researchers. For them, I would say, please do not be shy and try to talk to those guys who are more experienced to get their feedback and input to your work. Next slide, please. So PROFES, as you all might know, is a Core B conference. There will be re-evaluation in the next months, and it might be that we come back to you to give us some support there. The PROFES proceedings are, except I think 2 editions published within Springer LNCS. So the exceptions were the first one, and somewhere in the early 2000s, we were in another series of Springer for 1 year. If you want to follow us over the year, visit profes-conferences.org for updates. And if you want to organize PROFES in future, contact us. Anyone from the steering committee will be happy to help you then. So I wish you and us an exciting event with interesting talks, constructive feedback and discussions, and exchange as good as possible. So with that, I would like to hand over to my colleague in the program co-chair, Marco, for more details on PROFES2020. Thank you very much.
Okay, thank you, Andreas. Just a few words to present the content of this conference. So we received a good number of submissions this year, essentially in line with what we have in previous year. We were in doubt, but even with this worldwide pandemics, we were able to attract a significant number of submissions. So we received 20 full papers, and out of them we accepted 19. We also have a number of short papers. We also received, I think, a record high number of industrial papers, 10, out of which we accepted 6. So we see an increasing trend in the number of industrial submission to this conference, and this is encouraging in terms of improving the relationship with the industry. And also we have since last year a new track for journal first and conference second papers, and this year we received 2 submissions. They both were in scope, and so they were accepted. I have to thank all the chairs, in addition to Andreas, Luca Ardito, Michael Klaas, Liliana Guzman, Federico Tomasetti, and Antonio Vetro, that managed all the tracks, made all the revision process to work, and eventually they were able to select what I think is a good set of papers of high quality. And of course, I have to thank all the members of the program committee that performed the hard work and did all the reviews. As mentioned in the beginning by Maurizio, we organized our conference on 2 days. We selected a time schedule that should allow people from a wide area of the world to attend in a reasonable time. So we started at 1, also tomorrow we will start at the same time. There are 3 sessions per day. Every session has 5 papers. Every paper has around 10 minutes for presentation plus an extra 5 minutes for questions. The first topic of the day will be Agile. This year we received a large number of papers talking about Agile, and so we have 2 sessions, one today and one tomorrow. Then we have Test and Evolution, the new topic about data science and analytics. It is an emerging topic, social and human aspect, and the last session is about the more general topic of the development practice. And we will close tomorrow around 5:05 with a few notes. So during the conference, you can use this link to access a copy of the papers. So if you can read while the presenter or after the presenter provided the highlights. You can access this link. We encourage you to interact with the speakers on the YouTube chat, where you can provide comments and ask questions that will be answered in the question and answer part just after the presentation. If you follow us on Twitter, please use the hashtag PROFES2020 for live tweeting, and enjoy the conference. So I'm leaving the stage to Antonio Vetro, who is the chair of the first session about Agile topics. So please, Antonio.
Good afternoon to everybody. Welcome to the first session of the conference. As Marco said, it is on Agile methodologies. The first paper that we have is a study of the Agile coach's role. It has been written by Kadri Dalialiev, Ezekiel Scott, Frederick Milani, and Dietmar Pfahl. Ezekiel Scott will present the paper. I will be happy after the presentation to accept the questions that are coming from the audience and let you all interact with Ezekiel. Ezekiel, welcome to Profes. Thanks for being here, and the stage is yours.
Okay, thank you so much. Okay, my name is Ezekiel Scott, and I'm here to present a study of the Agile coach role. It's a paper that we did with Kadri, Frederick, and Dietmar at the University of Tartu, Estonia. So let me first introduce a little bit the motivation of this research topic. And if you are here, you probably know the popularity of Agile software development nowadays. So teams and companies usually prefer to use these methods and practices to build software, right? But you probably know that Agile adoption is not straightforward. So although these methods and practices are commonly easy to understand somehow, they are really are hard to put into practice, right? So for that reason, teams and organizations usually need help, and for that they hire professionals to get that help, right? And those professionals are commonly known as Agile coaches. So our research basically is trying to know who are they, who are these Agile coaches, and try to understand this role in the context of Agile software development, in line with previous research that have investigated the role of the Scrum Master, the role of the Product Owner, right? So in particular, we wanted to know what are the objectives of the Agile coaches, what are the methods they use to achieve those objectives, what are the challenges Agile coaches commonly face, the skills that are required by this role, and also the value that they add as perceived by themselves. To answer this question, we designed a study in which at the very beginning we prepare a semi-structured interview with open-ended questions, and then we approach a professional network in Northern Europe. So this is an online network, like probably you know it, and then this was at the beginning of March, and then after that we started with the data collection phase. In the data collection phase, we conducted these interviews, and basically 8 Agile coaches, agreed on participate in this study, and they are currently working as Agile coaches, and most of them coach between 1 and 5 teams. Also, half of them have more than 5 years of experience. After the data collection phase, we did the data analysis, and data analysis was based on theme analysis, basically according to our research questions. That these are the ones that I mentioned before, and then we just report the study and write it accordingly. So what we found, the first research question was about the objectives of Agile coaches, right? So we found that Agile coaches are mainly focused on 2 important goals, that is, educate and help teams, right? For example, one of the Agile coaches was saying that he or she provides a portfolio of trainings to the organization in which they basically deliver content and they teach to developers and teams on how to write user stories and how to perform or conduct different practices. Right? But also they mentioned that an important goal is to help teams to, for example, to focus much more in the goals and how to achieve the sprint goal, for example. Other Agile coaches were saying that creating communities or spaces for knowledge exchange is very important for this, because, for example, in this kind of communities or spaces, they put together Scrum Master, product owners, and other stakeholders, and they exchange knowledge and how about their experience, right? And finally, some other Agile coaches were mentioning improvement. Improvement is an important thing that basically they want teams to perform better in many senses. About the method Agile coaches use to get these to get these goals, is basically most of them were like mentioning coaching, right, and teaching as well. They made a difference between coaching and teaching, because coaching is more about getting the best version of the team and the individual, and teaching is more about the delivery of content, right? Another important method that they use is observation, right? I mean, so basically all of them I agree that observation in situ is very important to observe the behavior of developers and other people around. And unfortunately this year, like because of COVID-19 outbreak, like, I mean, there is a lot of remote work going on, right? So this was a big challenge, is like for the Agile coaches, because they were saying that it's really hard to observe the behavior of teams and developers if they do this remote work. Another method that you use that they mention is about facilitation, and it's like basically to facilitate, to create these spaces and workshops that I was talking before in order to deliver the content. Okay, the challenges they face is like probably on top of the previous one about remote work. One of the important ones that they mention is to preserve authority. On one hand, Agile coaches are usually hired as external ones. So we can say that this like creates kind of, it's hard for Agile coaches that are hired as externals, because they cannot enforce the rule, right? I mean, because they are external to the organization. And this is one thing. And another thing was that it creates also kind of personal conflict, because Agile coaches want to be also friendly with the people and the teams. So for this, for the participant, this is like was a challenge. Another challenge was to understand what's the real problem behind, and for that they said that it requires a lot of talk. I mean, they have to talk with different people in the team and to see what's the real problem behind. And another problem is the mindset, like, because they're saying that sometimes there is kind of managers or people with certain authority in the companies that they have a different mindset, and it's really hard to change that mindset. And it's also hard to convince them that to make Agile their organization, it requires structural changes. About the skills required by the role, the first one that was mentioned is the Agile knowledge. So that means like Agile coaches must know about a broad range of techniques, like, for example, not only Scrum, but also Lean and Kanban. And also they mentioned that people skills are important ones, because they have to talk with a lot of people and being empathic. Finally, coaching and teaching were also mentioned as important skills. About the value they add, we asked them how they perceive the value added to the company. And they said that the first one is about team development, and not only team development, but also individual development. So that means like after their participation or their intervention, they can see that teams are more grow up and people is like more satisfied. They can also influence other teams and the entire company, because they said that, okay, if there is a a team that is doing better and feeling better about what they do, the other team will try to copy that behavior. So that's a lot of influence. And finally, measurement, then that's related to the fact that Agile coaches can propose different ways to measure the improvements, right? But still they were clear that the biggest indicator is the mood in the room and how people take work. So this was very important. So as a conclusion of this work, we can say that the role aims mainly to educate and help teams. And also they use different strategies to achieve those goals, like, for example, teaching and observing. Finally, coaches also, as any professional role, can be face challenges, right? Those one can be preserving authority and the remote work, right? I mean, so because remote work was a challenge for them because like make difficult the observation. Finally, the value that they perceive is that they can improve team dynamics, right? in teams and individuals. So finally, we believe that these findings are relevant for new Agile coaches and organizations, and these findings also contribute to the construction of a professional identity. So thank you so much for your attention, and if you have questions, I will be happy to take them.
Thanks a lot, Ezequiel, for your presentation. I remind that this paper was a full paper. I forgot to tell before. So, Ezequiel, I have a question for you. Mm-hmm. You show that the skills that are required to Agile coaches, and having seen the skills that you found in your study, I was wondering what types of background they have, scientific background that they have, the coaches. If you could collect also this information. So they were coming all from IT studies, technical studies, or also from other types of studies. If you have this information.
Mm-hmm. Well, okay, but first of all, the participants really took care about their privacy. So there was really clear about that they didn't want to share so much data or who they are, because the community, especially in this region, is like quite small. So they will probably know. So they were really afraid of that. So we try to preserve the identity as much as we were able to do, and then we aggregate the data and so on. But I can say that as far as I know, Kadri, did most of the interviews, and he told me that they are like for different backgrounds, really different backgrounds, because we have often, they were experienced, but also there was, like, for example, one of the participants who was a lot of experience, right, and mostly about working experience, right. So yeah, this is the data that we know. But it's the interesting part was really interesting profiles, let's say, because they had a mix of teaching, for example. They had a mix of IT knowledge and like an interesting combinations, let's say.
Thanks a lot. I will now pick a question from the audience. There is a question from Rogart Hedal, who is asking, what about very complex domains such as automotive, telecoms? How big is the impact when there is a lack of domain knowledge in these situations? Any insight on this point?
Yeah, unfortunately, we didn't ask about that, about the domain in which they work. Yeah, this is like something missing there, but still we know they work with many teams. Like, in some cases, okay, as we saw, like between 1 and 5, but there was one of the participants working in much more teams. But yeah, they didn't mention also in the interviews that the domain knowledge was like the most important part actually, or a relevant part that was not clear from the interviews, but it was really clear that they emphasize or they stress a lot the people interactions. So for them, there was more problematic or one of the challenges was like trying to understand the problem behind, and they refer much more to like internal behavioral problems, like, I mean, so talking with the different people or the team members. So that was a clear stress on that, but not about the domain.
Okay, perfect. Thanks a lot. Unfortunately, we don't have time for our last questions that we received on the chat. However, I suggest to contact directly Ezequiel. And Ezequiel, thanks a lot for presenting and for being here at PROFES.
Okay, thank you so much. Bye-bye.
Bye. The next paper is again a full paper, and is again on Agile coaching. The paper is a systematic literature review on Agile coaching and the role of the Agile coach. It has been written by Victoria Stray, Bakhtavar Memon, and Lucas Paruk, and today we have the pleasure to have Victoria Stray here at PROFES. Welcome, Victoria, and I leave the stage to you.
Thank you so much, Antonio. Yes, my name is Victoria, and I will present the paper, A Systematic Literature Review on Agile Coaching and the Role of the Agile Coach, that I have written with my co-authors, Bakhtavar Memon and Lucas Paruk. I work as an associate professor at the University of Oslo in the Department of Informatics. I also have a research position at Sintef Digital in Trondheim, and I've worked as an IT consultant previously. The popularity of Agile software development continues to rise, and the adoption of Agile methodology is not straightforward. As entire organizations wish to adopt Agile, such transformation requires large, significant changes in roles, practices, tools, behaviors, mindset, and responsibility. It is increasingly common to introduce Agile coaches to help gain speed and advantage in Agile companies and assist with Agile transformation. Following the success of Spotify, the role of the Agile coach has branched out in terms of tasks and responsibilities. The role is also called a Scrum coach, Kanban coach, Lean coach, or DevOps coach. Agile coaches can be either hired consultants or a company's own employees who take up coaching roles. Coaches facilitate Agile teams and managers in adopting and implementing Agile practices, processes, and values. However, there are still a number of challenges in Agile adoption. Human-related challenges such as resistance to change, lack of effective communication, and insufficient experience of Agile methods and practices. So we wanted to conduct a literature review to explore what academic literature says about Agile coaching. More specifically, what it is and how coaching can help address challenges in Agile companies. And currently, more than 58,000 people on LinkedIn have Agile coach as a job title. And we had the two research questions. The first was, what are the tasks and responsibilities of an Agile coach? And the second was, what are the skills required of an Agile coach? The review procedure was based on guidelines for performing systematic literature reviews in software engineering by Kitchenham et al. The review's objective was to better understand what Agile coaching is, what Agile coaches do, and how they can help in the adoption of Agile methodologies in software development organizations. And we developed the search query iteratively, and we began by identifying relevant search keywords based on reading both academic and practitioner literature, and developed the search query that you can see here. The final search query was applied to Scopers in March 2020, in which 209 results were returned. Both inclusion criteria include publications in journals and conference proceedings, as well as relevant book chapters. We identified these studies by evaluating the abstract's relevancy to the topic. Studies that did not qualify for the inclusion criteria were excluded, as well as workshop proposals. And we designed and used a data collection form to record the full details of the study. During data extraction and synthesis, a thorough reading of each of the 67 included studies was performed to extract relevant information. We exported metadata of each of the results, such as authors, title, year, publication source, abstract, and document type into a spreadsheet. And the spreadsheets containing the scope research results, together with inclusion and exclusion decisions, is available online. Once data extraction was complete, the extracted data related to the research questions were closely analyzed to identify common themes. And we used thematic analysis. More than half of the studies are from the last 5 years, which shows that Agile coaching and issues surrounding it are gaining research interest and being more actively studied. Several research methods have been reported in these studies, and the most common are case studies, 19 studies, and grounded theory research, which was 14 studies. The majority of the studies included in the review are published as conference papers, and out of the 67 studies included, 46 are conference papers, 18 are journal articles, and the remaining 3 are book chapters. So now the exciting stuff. What are the tasks and responsibilities? The most common task of the Agile coach, reported by 12 of the studies, were to develop and train the teams, as we heard Ezequiel talk about in the last presentation. And next, an important task was to support stakeholders and managers to understand and apply Agile methods. 8 studies reported that the coach had to facilitate and monitor effective implementation of Agile. Other tasks were understand context and metrics, to adapt the Agile implementation to the organization, help in creating guidelines and setting goals and roadmaps, build trust, remove bottlenecks, and select a pilot study. So 12 articles mentioned that developing and training the Agile teams were a major task of the Agile coach. They should provide support, lead the team towards self-organization, and help teams explore their potential. They often teach Agile methods and techniques and conduct workshops. The tasks of an Agile coach are not limited to the team level. An Agile coach facilitates the adaptation of Agile methods and practices by proposing required adjustments and helps all the practitioners to overcome their problems during the transition process and facilitate the change process. A good coach communicates and collaborates with all the stakeholders involved in the Agile transition process, such as top management. And they also directly coach the people involved in the Agile transformation by teaching them what they need to know to be familiar with their new roles and responsibilities. Additional duties of an Agile coach include supporting Scrum Masters and distributed Scrum teams and supporting product owners. Agile coaches were typically based within a team and working with several teams within the organization, while also supporting it as a whole in collaboration with other coaches and leaders. Some coaches worked on shifting the manager's focus from what the teams were doing to why they were doing what they did, and training them to have an Agile mindset, for example, not to dictate a date and budget without involving the teams. There are 4 main types of skills that seem essential for Agile coaches: leadership skills, project management skills, expertise in Agile methods and practices, and technical skills. And the most important is leadership qualities. Examples of such skills are good communication skills, an understanding of teamwork and team dynamics, team building, and conflict management. An Agile coach needs strong social skills to facilitate learning. Furthermore, they should have a range of traits supporting these skills, such as positivity, persistence, and patience. Second, an Agile coach must have some project management skills to achieve goals and meet success criteria at specified times, such as skills in change management, expertise to facilitate identification and management of risk in the system, knowledge management skills, and the ability to help teams make more realistic estimates. Some studies, they reported that they need technical skills to help individuals and teams design and develop software, systematically dealing with the transition or transformation of an organization's goals, processes, or technologies, and identifying risks. One study also found that Agile coaches are often confused about their role on an Agile team and what is expected of them. A coach must therefore be able to tackle confusing and unclear requirements about what their role entails. So this systematic literature review was conducted to understand the role of the Agile coach, as there is a lack of understanding of what Agile coaching is, what Agile coaches do, and how Agile coaches can help in Agile transformations. The thematic analysis of 67 papers provided insights into the tasks, responsibilities, and skills required of Agile coaches. So Agile coaches help overcome challenges in large-scale Agile adoption, such as resistance to change and difficulty in understanding and implementing Agile methods at scale. They teach and mentor teams, empowering them to ask relevant questions, discovering the knowledge already hidden in the team, resolving conflicts, and facilitating the overcoming human impediments in overall process improvement. They also play a role in removing barriers to team autonomy and help managers and stakeholders in understanding the Agile journey. Future work can involve investigating the inherent challenges of Agile coaching itself. This may include issues and problems hindering effective Agile coaching and countermeasures that coaches enact to overcome these challenges and make their work more effective. It would also be interesting to investigate tools and techniques used by Agile coaches to support them in their work. And one example of future work that we did, inspired by this systematic literature review, was a qualitative study where we investigated the role of the Agile coach by interviewing 19 coaches. And you can find the preprint online. Okay, thank you so much for your time.
Thanks a lot, Victoria, for your presentation. I will start actually from the question that I couldn't make to previous study, because I think that it applies quite well also to your presentation, and I think you also partially already answered, so I'm asking for a confirmation actually. The question was from Anastasia Tsalic, and who asked if you observed an activity of Agile coaches also towards the organization, not only towards the teams. My impression is that from your literature review, it emerged that also the entire organization could receive support from the Agile coaches. Do you agree? Is that right?
Yes, that is a very good question and a good answer from you. It's absolutely correct that the coach from the systematic literature review, it shows that they don't only coach team members or individual team members or teams, but also the whole organization and also the customers. So they're the product owners and the Scrum Masters. So they're important for the whole Agile transformation.
Great, thanks for answering. And another question regards pilot projects. So you mentioned that in a couple of studies, Agile coaches could help also in defining or selecting the pilot projects. And this is something that by overlapping the two presentations, the finding from the two presentations, the one before a year, so this is something that is new, that was not reported in that study. And could you say something more on this activity of selecting a pilot project and in what consists and what is helpful for?
Yes. So now many organizations, they want to expand their Agile way and Agile way of working to the whole organization. And not only, for example, the software development project, but also more business-oriented projects. And the Agile coach can help with choosing what project is a good fit for trying more Agile ways of working and help the project with implementing the process and the values.
Thanks a lot for answering. And Again, thanks for your presentation and for being here at PROFES.
Thank you for having me.
Goodbye, Victoria. We will now continue with another full paper and another systematic literature review. We will change role, though. We will speak about leaders. The paper is Agile Leadership and Agile Management on organizational level, a systematic literature review. And it has been written by Sven Theobald, Nils Brenner, Alexander Krieg, and Kurt Schneider. And we have 3 of them for the presentation. So welcome to everybody. And please, the stage is yours.
Thank you for having us here today. We are a team of 3 researchers. My colleague Sven Theobald from Fraunhofer Institute, my other colleague Alexander Krieg from Boris Klogger Consulting, and myself, Nils Brenner. I'm from the Leibniz University in Hanover, and today we present our paper Agile Leadership and Agile Management on Organizational Level, a Systematic Literature Review. And let's talk first about the motivation behind our paper. Today's companies are under a lot of stress because they have to operate in fast-changing markets, have to deal with digitalizations, have continuously to adapt to new technologies. And the whole development has to be customer-centric in order to get an advance over other competitive companies. And for that, to master all these difficulties, companies have to form an agile organization where agility is not only embraced on the development level, but on all levels, especially on leadership level and management levels. What's the problem here is that there's a missing understanding of how agility looks on the organizational level. And there's also a missing overview of the scientific literature in this field. And therefore, we decided for the first step in this research direction to conduct a systematic literature review in this field of agile management and agile leadership. And for that, we formulated 2 research questions. The first one is, how is agile leadership and agile management on organizational level defined in scientific literature? And the second one is, what motivation for agile leadership and agile management on organizational level is provided by scientific literature? And I have already talked a lot about management and leadership, and in order to form a common understanding of these concepts, I want shortly present the classic concepts of management and leadership. And management consists of the planning activities, human resource responsibilities, organizational tasks, and controlling. And on the other hand, leadership is responsible for providing goals and vision, align employees with these goals, and provide motivation for employees. And now I will hand the word over to my colleague, Sven Theobald, for the results.
Thank you. Hello, also from my side. I will talk shortly about the results. So our final set of papers consisted of 14 papers that mostly dealt with agile leadership. And I want to provide you with a crisp and condensed overview that also does not follow the same line of argumentation like our paper, but try to have a condensed view in order to be able to present it. So in our first research question, we tried to identify aspects that were related to agile leadership and agile management. So our goal was to define what is agile leadership and what is agile management about. And we found, for example, that there are certain skills and traits that are related to agile leaders. For example, an agile leader has to be adaptable, he has to be a continuous learner, and he has to have the culture of experimentation. So he has to be willing to try things out and fail fast. A very important task of agile leaders is to set the purpose for the team and to align the team with a common direction. So an agile leader is responsible to establish shared values and also communicate the meaning and the purpose to the team. Towards the team, Agile leaders have the role of a coach, of a mentor, of a facilitator. So they do not manage the team anymore or even micromanage the team. Instead, they lead the team. So they let the team self-organize and they provide an optimal environment so that the teams can thrive. Throughout the organization, Agile leaders take over the strategic role as change agents to drive the Agile transformation. And in order to do that, they have to have effective communication throughout all levels of the organization and all business areas of the organization in order to be able to kill and hide bureaucracy. So when you have a look on all these aspects, you will notice that most are more related to leadership than to management. This could be because Agile teams should be self-empowered and self-manage themselves, and leaders only take over the role of a leadership, classical leadership. In our second research question, we had a look at what motivations exist to change towards a more agile leadership and management. And we have this line of argumentation. So we first looked at typical aspects of traditional organizations, and we found them to be described as having a top-down and disciplinarian style leadership, having centralized decision-making, and typically it's experts that define the work that other people have to do. Now, those organizations face new drivers. So we have digitalization, we have an increase in knowledge work, and in general, the business environment becomes more volatile, more uncertain, more complex, and more ambiguous. So traditional management is no longer suitable to address all those drivers. It was found to prevent innovation, to avoid changes, to impede the speed of the organization, also the speed of decision-making. So traditional management was not suitable to cope with all of those aspects. Agile leadership, on the other hand, it addresses many future demands like flexibility. It enables fast decision-making. It helps us to handle complexity. So this is a new thing that becomes more and more important. And how does Agile leadership address those future demands? It's by having enabling leadership, so providing a suitable work environment for the team, so the team can not define their work on their own, but self-manage how they work, and leaders more becoming those drivers for cultural change throughout the organization. In general, change becomes more important for organizations, so people have to drive that, and Agile leaders are the best people to drive these cultural changes. And now I hand over to Alexander Krieg, who will provide an overview over the wider setting of our research about our past work and also a little bit about our future work.
Thank you, Sven, and I also want to welcome you to our presentation. In the next 2.5 minutes, I want to give you a brief insight about the idea and how everything started with us and what our planned future works. Actually, the idea started around 2016 with the idea of drawing a first map of Agile organizations. And it all started with the release of our organizational-based Agile maturity model, which you can download for free in the internet. So this model had the aim to achieve a first total overview about all relevant, not just technology areas of an Agile company. A little further, in 2017, we started to design first structures and question blocks for the survey, because we want to use the results of this survey to draw finally this map for Agile organizations. And furthermore, in about 2019, after some structures and question blocks were built, we started the creation of this SLR, which we just represent to you, because we want to achieve a scientific overview and a scientific baseline. Because on this baseline, we want to use for the survey, to build a survey finally on this scientific baseline. So the planned future work we have are, I can say it's in about 2 dimensions. The first dimension is to close the gap between the scientific view and the industrial experiences and needs. Therefore, we already isolated some next research questions for further research. We will start with interviewing Agile experts and practitioners to achieve an overview about the challenges and the impediments with which an expert has to cope while implementing agility in the industry. And last but not least, we want to finish the planned survey on the management level to build up this map for agile organizations. And the second dimension is to create an interdisciplinary base for future research, because we realize to solve the questions about the future of industry, digitization, and agility, we need a wider research approach from different science areas. So we would be very happy if you contact us and ask us questions, give us feedback, and also if you would like to join and support us, feel warmly welcome. These three people you see, you can contact, and we also do have a webpage where we try to represent the newest research. So don't hesitate, go there, contact us, support us, be very welcome. Thank you very much for your interest and your participation.
Thanks a lot for your presentation. Thanks to Sven, Niels, Alexander. We have already a question from the audience, and it is a question from Robert Eidal, and who is asking, were there any work on combining plan-driven development with agile development? For example, agile is often put within the V model in automotive to drive the overall project.
Yes, thank you for the question. That's a good question. I actually started my PhD process, and I will try to identify how agile teams can efficiently work in an environment that is more traditional, like in a systems engineering environment, like in the automotive company that you said that the V model is used, and how agile teams can work in these structures. And this study today was a step towards this direction, because if we identify how leaders can become more agile, and it's mostly cultural issues, it's not implementing certain agile methods or practices, this will be a good step in shaping the environment, so the environment becomes more suitable to a better collaboration with agile teams.
Thanks a lot for your answer. You said about leaders becoming more agile. What about managers becoming more leaders?
Yeah, as you noticed, we found we had two search strings trying to covering management, agile management, and agile leadership. And finally, we couldn't select any paper for agile management. So this is not a term that is used in the agile community. You mostly talk about leadership. And you will see that leadership becomes more important, but that also doesn't mean that maybe management tasks will vanish completely, because you need a certain alignment. So that's really the question, how managers can become more leaders and becoming agile leaders in this case.
Another point is that the subjects of management and leaders, mainly in sometimes in the literature and also in the industry, is very much mixed up. So to get a clear idea about what truly is leadership, what truly is management, and how to live both sides in one person as a leader is a hard, challenging question. And in our SLR, we really try to divide both areas and to make clear what does it mean to lead future teams and future companies, and how to become more agile leader than a manager.
Thanks a lot. I think you did a great job in clarifying better these two roles in your work. Last question is more descriptive, requires more a descriptive, let's say, answer, because for your review you included only works written in English or German. And well, only you included beyond English also German. Let's turn in this way. And so my first question is whether if you remember how was the composition of the final the final studies, if there were both in languages or more German written studies. And the second question is were more papers appeared in conferences or in journal?
So it was more papers from journal papers, not from journal, from conferences.
Okay.
And we only had, I think, one paper that was written originally in German, but there was also an English translation for it. It was actually from a colleague from another Fraunhofer Institute, talking a little bit about Industry 4.0 and in general the changes towards leadership, that arise. Yeah.
Okay. So many thanks again for being the three of you here and for being at PROFES. And we will now, so goodbye, thanks a lot.
Bye.
Thank you very much.
Bye.
We now, one of the questions was, it was mentioned the automotive sector, and here we get for the next presentation the automotive sector. It is an industry paper. The title is A Portfolio-Driven Development Model and its Management Method of Agile Product Line Engineering Applied to Automotive Software Development. It has been written by Kengo Hayashi and Mikio Aoyama. And we have today for presenting it, Kengo Hayashi.
Yeah.
Welcome, warm welcome to PROFES. And please, you can present the paper.
Yeah, thank you. Thank you for introducing. I'm Kengo Hayashi of Denso Corporation. I'll present our practice title as shown on here. Yes, okay, here is scenario of my talk, okay. Well, the background of my practice. Denso I belong is a mega supplier for automotive manufacturers. In Denso, I engaged to develop a mass production, which is one of advanced safety systems. This system is for reducing damage in an event of collisions by using ultrasonic sensors. This domain technology competition is very intense and product evolution is very fast. And it is expected to expand into many vehicle variations. So we need to deal with both variability and agile evolvability concerns. In order to tackle this issue, we are practicing software product line engineering. In SPLA approach, at first, developers build core assets for a product line in domain engineering. After then, developers derive individual products in application engineering. If the approach works ideally, we take almost no cost for application engineering. But in on-site practice, cost for application engineering does not become zero, though each development is relatively small. Moreover, we must develop multiple products concurrently and continuously. As a result, human resources management becomes complicated and delivery risks have to be increased. Now, as a prerequisite, in addition to this, projects in a product line have interdependent on each other due to shared resources and core assets. So we try to take portfolio management in comprehensive management over multiple products development in application engineering of SPLE. In a conventional approach, requirements are fixed and resources and delivery are adapted for requirements. In an agile approach, resources and deliveries are fixed and requirements are adapted. In our approach, resources are only fixed, deliveries are coordinated, and requirements are adapted. This approach aims to sustain stable, comprehensive development in application engineering by prioritizing to the human resources constraint. Yes. This figure illustrates portfolio-driven development model for application engineering in SPLE based on portfolio-driven approach. This model consists of 3 layers of management that are portfolio, product, and sprint level. By coordinating with each layer, a trade-off triangle of requirements, delivery, and resources is optimized in comprehensive development over multiple projects in multiple product lines. I would leave the detailed explanation of a model to our paper. Here, I would like to explain practice points of each management level. The first, from sprint level, that is the lowest management level of our model. In this level, team management is performed and actual development is executed by developers. Sprint level's responsibility is to quantify shared resources to productivity and to manage a team to stabilize its productivity. To measure and control the productivity, a team develops products by time box development. This level gets controlled by the upper level. Development items are prioritized at product level and so on. To stabilize productivity, the following practice is tackled as ingenuity. Firstly, development items are divided and defined according to variation points. And each variation point is prioritized from the top of dependencies. Each item is developed independently through design, implementation, and testing, much like Agile development. This practice, we prevent that some items remain in process in each sprint. And it also reduces the frequency of regression testing due to related changes. In this way, sprint level engage to stabilize productivity based on an Agile framework. The next level is product level. At this level, its activity is basically similar like as ordinary project management, but a little different. Product level takes control by portfolio level. A project manager or a product owner defines a product backlog as development items of a product. The product backlog is optimized by a release plan determined at portfolio level. Based on the backlog and release plan, the manager coordinates a delivery date with stakeholders. Product level engage to stabilize the prerequisites for individual iterative projects. The top level of our model is portfolio level. At this level, program management is performed by a portfolio manager or a project management office. Program level's responsibility is to manage over multiple projects in multiple SPLs and to prioritize projects based on productivity requirements and required delivery dates. Here, the manager plans and acquires human resources and organizes teams based on a business plan. Requirements and delivery dates are optimized with reflecting the dependency of each product. On software product line engineering, core assets may be concurrently evolved by developers in domain engineering. So development size and requirement amounts of product is changed according to the order of development. The manager considers this characteristic and she plans with understanding interdependency of products. As this practice, we have refined the resources plan in a period on aims. For progress monitoring, we refine the plan every week, foreseeing 2 weeks. For projects planning, we refine the plan every 2 weeks, foreseeing 3 months. For resources procurement, we refine the plan every quarter, foreseeing 1 to 3 years. In order to play such a puzzle game, we need a rhythmical time box development as an abstracted fixed period and supplement of unified stable productivity and requirement quantity in the same unit system. In this way, portfolio level engage to make decision for maximizing ROI all over comprehensive SPLs. And we can sustain multiple products development of application engineering of SPLE. Now, we have applied our proposed method to an actual development of automotive software system. Application period is about 15 months. The number of practice teams is 2 teams. There are 1 portfolio manager and 3 project managers. I participated as portfolio manager in all projects. I would like to introduce the effective using actual project data. The first is predictability of productivity of resources. We measure the development volumes of each sprint as productivity and its volatility as predictability. Productivity naturally fluctuates when developers are changed, but volatility is suppressed to 10% or less in sprints of 80% or more. And productivity is highly predictable, while resources are kept constant. In application engineering, there is work level repeatability, so the productivity will be easy to stabilize. The next is predictability of development size of products. We measured a ratio of actual to estimate of development size of the products in 48 releases. A project manager estimated relatively based on the amount of development of similar previous products. Since the reusability of product line engineering processes, it was confirmed that the predictability of development size will improve if developments are iterated. Based on these prerequisites, we measure the controllability of the 3 entities of a trade-off triangle by coefficient of variation. As a result, the coefficients of variation are decreasing from requirements, delivery date, capability of resources, and to resources. With the proposed management method, we have controlled a trade-off triangle with variable requirements and delivery. The biggest achievement is that we were able to continue 48 releases without failure for 15 months. Here, a short discussion. The first is the application of this method limited to SPLE application engineering. Now, this model takes advantage of application engineering, repeating similar tasks iteratively. So it's applicable for work level process iterative development. The second, what are the limits of this method? It works well if an application engineering team for a product line fits into 1 team. Allocation of multiple teams will be more redundant, but more difficult to maintain efficiency. The last, can anyone be a portfolio manager? No. She needs to have some knowledge and experience of core asset architecture. Otherwise, a credibility of a resource plan may be lost, and the development side may be confused. Anyway, for continuous development, I think it is essential to break down complex problems and collaborate between organizations. Yes, conclusion. We propose a portfolio-driven development and management method of 3 layers on SPLE. We apply this method to our automotive software systems and demonstrated an improvement of manageability. The proposed method are continuously used in our development and produced more than 100 products. I would expect our contribution to practitioners for sustained development in SPLE. Yeah, thank you for your kind attention.
Thanks a lot, Kengo, for your presentation. before asking, there is time for one question, and before asking the question, I would like to remind the audience that since you are following on YouTube, you might follow the live with a little bit of delay. It can vary from a few seconds to more. So our suggestion is to time to reload the video on the browser in order to be on sync with the live event, or to move the cursor towards the right if you notice that there is space to there is a bit of delay, so that also your questions will come synchronously to the event. Given say that, I will now go back to the paper with a question for Kengo, and you say that one of the difficulties will be to scale the approach, and I imagine that also a further factor of complexity is distributed teams, because that I know that Denso has multiple locations all over the world. So are you planning to face also in future these aspects, or applying the method when you have multiple locations?
This application is one location. So yeah, this time I didn't practice multiple locations, but so multiple location is very get difficulty. So we will try to multiple location this application to this practice. I guess.
Okay, thanks. So you are planning for the future, and we look forward to know about the results of the experiment. So thanks again, Kengo, for your presentation and for being here at PROFES.
Yeah, thank you.
Goodbye. We are now approaching the end of the session. We have the last presentation. That is a short paper. The title is A Practice-Informed Conceptual Model for a Combined Approach of Agile, User-Centered Design, and a Lean Startup. The paper has been written by Maximilian Zorzetti, Ingrid Signoretti, Eliana Pereira, Larissa Salerno, Cassiano Morales, Cassio Trindade, Michele Machado, Riccardo Bastos, and Sabrina Marczak. For technical reasons, we will send now live the recorded presentation for this of this paper. However, please stay for the Q and answer session, because the Maximilian Zorzetti will be will be here live to answer your questions. So now I ask Simone to send the video. Thanks a lot.
goal is to develop a conceptual model that integrates these three pillars, namely Agile software development, user-centered design, and lean startup. To do so, we define three research questions, the first one being the main one. How can Agile, lean startup, and user-centered design be conceptualized in one integrated model? We'll answer this with the conceptual model itself, and to guide its development, we came up with two other questions. What concepts are Agile, Lean Startup, and User-Centered Design made up of, and how do Agile, Lean Startup, and User-Centered Design intersect? Since this is a preliminary study, our results only partially answer the first and the second research questions. As for our research method, we are using design science as the main approach to developing the conceptual model. Our modeling effort follows this 5-phase model depicted here, although in this preliminary study, we've only performed the first 3 phases. In the first phase, the awareness phase, we seek to identify concepts pertaining to the 3 pillars. In this study, we've used the case study as a data source to get these concepts from. In the suggestion phase, we mix and match the concepts into a rough model that makes sense. This is when the main creative processes take place. Finally, in the development phase, we formalize this rough model using a standardized language, such as UML. So, as I mentioned, we performed a case study to fuel our modeling effort. Our case consists of a large multinational IT company with over 7,000 employees worldwide. This company is currently trying to spread the use of the combined approach throughout it, and to that end, it has flown entire development teams overseas to train with a consulting firm specialized in it. We have studied 2 of these development teams that were rated as experts in the use of the combined approach for a 6-month period. During this period, they were stationed in a specialized development lab while working on their everyday projects. This lab was built inside our university campus specifically for this purpose and provides modern development facilities for the teams. During these 6 months, we observed the teams doing their daily work. We held interviews to better understand what they do and what roles their teams are made up of. And we also held focus group sessions to discuss the combined approach itself. We then followed Krippendorf's content analysis guidelines and extracted codes from our dataset, combining them into categories and concepts to fuel our modeling effort. Okay, now for our results. We separated the identified concepts into 7 packages. The 2 main packages are the problem and solution packages. We found out that the teams pretty much spend their development process either in a problem understanding phase or a solution development phase. So activities related to problem understanding, such as observing and interviewing users, are found in the problem package. As for the solution package, we get more typical Agile development activities, such as setting up the development pipeline and developing user stories. Although here we also see the presence of Lean Startup's build, measure, learn cycle. We also left separately a pivot activity, which the team stated that could happen at any point. If the teams figure out that what they are currently doing is wrong, they could, for instance, pivot away from pursuing a given type of solution and start focusing on another one. We also set up meeting and role packages. The first one defines the meetings that take place during the development effort, such as iteration planning meetings and daily stand-ups. For the role package, we identified the 3 roles that make up the teams. In summary, the product designer focuses on UCD activities, the product manager focuses on Lean Startup activities, and the software engineer handles most of the development work. Teams also have an anchor, a software engineer which helps in bridging the communication gap between other engineers and the business, customer, and user side of things. We also set up 3 other packages to categorize the various techniques the teams use. So we have techniques pertaining to extreme programming, such as unit testing and pair programming. For Lean Startup, we have minimal viable product, and for user-centered design, we have interviews and personas. So what's interesting about what we found is that the concepts we managed to extract are not directly related to software development, and they take on a more genetic outlook. So instead of concepts like coding, we get story development. And this is because the teams do not see themselves as software developers first, but instead as problem solvers. Once one of their clients demanded a faster spreadsheet generator than the one they currently had. So one of the teams mapped how much it would cost for them to develop a new system and how much it would cost just to buy new computer parts for the host machine. After weighing the costs, they ended up just buying new computer parts, solving the customer's problem without writing a single line of code. The teams also report that their process is quite organic, that there's a lot to the mindset behind the way they work. This can be seen in the way we structured our conceptual model, by separating the techniques into their own packages, as the team stated that they use their techniques in an opportunistic fashion, and not really in a pre-planned way. In conclusion, this preliminary conceptual model is a first step towards a theoretical foundation to develop a new research on the combined approach. As of now, this model is on the low level of the abstraction side of things. For instance, it doesn't represent higher level concepts such as principles or values. So for future work, we will continue with a bottom-up approach to modeling, starting by complementing the model with literature concepts. So for our next steps, we need to identify concepts from literature, merge said concepts into our model, see if there's a better alternative to UML, and finally evaluate the model using our partnership with the multinational IT company. So for your time, I'll be answering your questions now. Thank you.
Thanks a lot. Please apologize for the technical problems at the beginning. We were able to fix them. We are here for the Q&A. Max Zorzetti, thanks a lot for being here, Max. Sorry, please apologize also you for the small problems.
No, it's fine.
One question for you. What kind of do you think? What kind of tools that can be developed in order to support better in the future the combination of the approaches? Have you ever thought about this aspect?
Yeah, right. So I'm part of a research team that is working together with this multinational IT company, right?
Yeah.
They are trying to spread this combined approach throughout the company, and they asked us to help them do it. And what we are currently doing is developing what we call an acceleration model to help spread the combined approach. It's kind of like a maturity model of sorts. And the whole idea, the whole motivation behind this work that was just presented was to establish a foundation so we can develop the acceleration model on top of. In sum, we're developing a maturity model for the combined approach with more specialized and well-structured mechanisms to help the company.
Thanks a lot, and I hope you will consider also as the work proceeds, you will consider again PROFES to share the results. And thanks a lot, Max, for being here. We are now closing the first session of PROFES 2020. We will have a break of 10 minutes. We will start again at 2:35 sharp. We'll be on time. And the next session will be on testing. Remember to refresh times to times YouTube in order to be synced with the live event. And again, thanks a lot for being here at PROFES. We'll meet later in 10 minutes after the break with the test.
Welcome back to the PROFES2020 conference. I hope you all enjoyed our virtual banquet that we had in the last 10 minutes. This second session will be about testing and evolution of software. We will have 5 papers also in this session. Again, we will have 3 full papers, 1 short paper, and 1 paper from the industry. The first presentation that we will have will be held by Daniel Guaman, and he will present a paper by himself, Jennifer Perez, Juan Garbajosa, and Germania Rodriguez, named A Systematic Oriented Process for Tool Selection, the Case of Green and Technical Debt Tools in Architecture Reconstruction. Welcome to the PROFES conference, Daniel, and I leave the show to you.
Okay. Good afternoon, everyone. My name is Daniel Guaman, and I come from the Computer Science Department of Universidad Técnica Particular de Loja from Ecuador. It's a pleasure for me to participate in the PROFES conference. I am going to present our work, which title is A Systematic Oriented Process for Tool Selection, the Case of Technical Debt Tools in Architecture Reconstruction. The contents of my presentation are the following: the introduction, the problem, the objectives, our proposal, a systematic oriented process, the case that we have used to evaluate the proposal, that is the evaluation of green and technical debt tools in architecture reconstruction, the conclusions, and the future work. Well-established research methods in software engineering, like systematic literature reviews, systematic mappings, or case studies, are effective to explore emerging issues, since they are systematic, replicable, and about bias, providing reusable knowledge. But what about the exploring new tools? Software engineering undergoes a continuous emergence of new technologies that at the same time entail the search of tools to support them or the construction of new tools. The standard IEEE ISO IC provides us a guideline for the evaluation and selection of case tools. Our contribution in this work is tailoring the standard with systematic activities in the guided process that allow us to select and evaluate a set of tools that best fit the needs required for a given context or objective. A problem when we need to search and evaluate tools in the lack of knowledge, and that we usually use non-systematic and replicable processes. So the problem to address this is how to tailor the standard to be systematic oriented, and how to determine which tool exists. Could you use some research method to search a set of tools? This work addresses these problems, prescribing systematic oriented activities that allow not only a selection, but also the evaluation of tools generating reusable knowledge assets. The general objectives in this work is to tailor the process of the standard to be systematic oriented. We have addressed a set of the specific objectives to define the process with systematic techniques and activities that allow its replicability and reusability, to prescribe the reporting of recommendation and findings, as well as specific assets with reusable knowledge that will be helpful for software engineers in the selection process and in the future. In addition, it's necessary to evaluate the viability of the process, and we have conducted an evaluation case to illustrate the adoption to identify and select tools that support architectural reconstruction activities to extract energy metrics and technical debt metrics. So the standard has been designed to discern, based on quantitative results, the one case tools that best the needs required for a given context. However, the standard in this work has been tailored to give it a research and exploration approach using new activities like systematic search, analysis techniques, and decision-making tree. In the research community on software issues, there are 2 factors that generate green concern: technical debt and software sustainability, which are considered critical, especially in a designing and coding phase. In the next slides, we present the application of the standard tailored in a case study that, following a guide process, allows to select and evaluate a set of tools related with architectural reconstruction that support green and technical debt. In the preparation, as the first phase of the process, we define the objectives, research question, expectation, characterization criteria, and hypothesis. All of them must be coded to guarantee the traceability and checking during the next phase. In our case study, the objective is to recommend a set of tools that can be used in technical depth and energy consumption. Our defined expectations are to identify and evaluate set of tools that use static and dynamic analysis. The characterization criteria are the features that allow us to delimit selection and classify the tools, include or exclude them in the search. Finally, the hypothesis allows us to validate if the tools cover the proposed objectives. The complete tables of the expectation evaluation criteria and hypotheses are provided in the paper. In the structuring phase, it is necessary to use one or the combination of research methods to cover all needs and requirements established. In this phase, we include a systematic literature review and web search to give response to need, as the search and selection of application from GitHub open repositories, generates data for analyzing technical depth and estimation the energy consumption. The process defines those search using a string will define as a primary search we perform at Isler, for which we obtain the default tools, and then we perform secondary search from web search and Eclipse plugins, having a total amount of 62 tools from these tools. The objectives and requirements were used to include or exclude the tools for producing the list of candidates from the search. And finally, we include 41 tools in the list of candidates. We are going to see the resulting list in the following slides. This phase is considered important in the tailoring of the standard. In this phase, we define 3 research questions that must be answered, reporting them, and the most important thing. The reporting information must be synthesized into tables that will be reusable assets for software engineers. The first research question allows the tools to regroup according to the techniques, the input and outputs, and if they have as proposals supporting the evaluation of technical depth or energy consumption through architectural reconstruction activities. Through the second research question, we identify the purpose of each tool and the metrics that can be obtained, such as complexity, dependencies, and maintainability to evaluate technical depth, as well as metrics related with energy consumption. Finally, the third research question allows us to know if the output provided is used to understand and this works in an operating system under a specific license type. The last phase in the tailoring process is the selection, in which some tools or research findings supported by the decision tree are presented and recommended. The decision tree allows us to follow a road that, based on the various defined criteria, supports engineers in the selection of a set of tools for a specific work or research context. The decision tree is composed by 3 types of nodes and the transition between them. The decision nodes are represented by squares, transition nodes, no decision, are represented by circles, and left nodes with a final decision are represented by a triangle. The transition between nodes is represented by an iRobot label with a select option. The option is an instance of the criterion that represents the column where the arrow is drawn. The criteria are the objectives, license, use, type, input, output, activities, programming language, and decision. In addition, these 3 models also help to determine a set of findings and recommendations. For example, to select a set of tools to evaluate energy consumption, depending on the license and activity supported as extraction, analysis, and visualization, we have options like Power API, PowerStat, and RapIA. As a result of the selection phase, we propose some recommendations, like when you need to evaluate technical depth on a Cube, Codacy, and Designite are tools recommended by the license type because they support application written in Java, C#, among others. When you need to evaluate energy consumption, we recommend RapIA, Power API, Ocean, and PowerStat. Our research finding, we propose there are tool technical depth and energy consumption combining static and dynamic analysis. Use plasma and deodorant to assess technical depth, code smell, and bad smell from the point of view of code or design. At the end of our work, it can be concluded that this work presents a tailored, standard, systematic-oriented process for the evaluation and selection of tools that address emerging areas, avoiding bias and promoting knowledge reusability. The process adoption has sustained reusable asset as the report and is synthesized information through comparative table and decision tree. It has been demonstrated to a case study. As future work, it will be necessary to formalize the management and extension of their reusable asset. Well, it was my presentation. Thank you for your attention. If you have any question, it will be a pleasure to answer them.
Okay, so I thank you for your presentation, for your interesting work about the extraction of metrics from software code. I do not see any comment, any question still in the comments, so I will open with one question myself. So first of all, you kept into account code metrics, technical depth metrics, and energy metrics. So from a point of view of green coding and sustainability. So do you see the possibility of expanding this work by keeping into account any other typologies of metrics for the evaluation of code? And like I see maintainability metrics or software testability and so on. And also, do you also seek possibly for correlations between the different families for metrics to see if you can use the output of those tools that you suggested for the different aspects for seeing if one type of metric has an influence on the other one? I think this could be a very interesting contribution, and I also think that there is some vacant point in the literature about tools for doing this.
Okay, thank you for your question. The principal objectives in the work is to find some tools to extract metrics, and then we can use in some different process. For example, we have to find the correlation between technical depth, especially quality, with energy consumption. In this case, for example, we use tools as SonarQube and RapPL, OSHI, and PowerStat. The main idea is to extract and analyze specific metrics such as CPU consumption, RAM consumption, and respect to technical depth, we have to analyze, for example, lines of code, complexity, cyclomatic complexity, and combine and analyze the correlation between them. In this case, when we identify some metrics, we have to build or analyze the result in another tool. This is the objective in this work.
Okay. So I don't see any other comments for the presentation. So I don't have any other questions for your work. So good job. Thank you for your presentation. And so we can move to the next paper, to the next presentation of this session. The next paper will be again a full paper. It will be presented by Ben Monaghan. It is a work by Ben Monaghan himself and with Julian M. Bass. And the paper is titled Redefining Legacy, a Technical Depth Perspective. So welcome to the PROFES conference, Ben, and I leave the show to you.
Hi, thank you. Hello everybody and good afternoon. My name's Ben. I'm a PhD student at the University of Salford and I'm presenting my paper, Redefining Legacy, a Technical Depth Perspective. So, legacy is an issue which is persistent for many years. It's pervasive in most companies. Anyone that's got any professional experience will have probably had some involvement with legacy applications. It's particularly present in sort of large industries, and the sort of motivation for our research was that we felt that sort of current conceptual definitions don't really give much insight into what it means to have a legacy application or what it means to manage a legacy application. Definitions range from they're old, it's dated languages, they no longer support business goals, and anything in between. So to this end, we thought, well, technical debt is growing in both industry and academia. It's a useful term in terms of it bridges the gap between technical and non-technical, and it gives a way of capturing the sort of state of software, its quality, the impact of its quality in terms of cost and development time. So the first step we thought was, well, what is it like for practitioners who actually have large-scale legacy applications that they have to manage? So we came up with the research question, how do practitioners describe their experiences of managing large-scale legacy applications? To this end, we conducted 16 semi-structured open-ended interviews. We used snowball sampling. We used our initial sort of professional contacts in the first instance through the university and ourselves. We tried to get a broad range of practitioners, so not just technical, but also non-technical. Legacy isn't just it's not just a software development problem, it's a decision maker problem. It affects management as well as developers. And just to give an idea of the sort of people we managed to get in touch with, so a range of people, enterprise architects, head of product delivery, CIOs, DBAs, principal architects, quite a range of industries as well. So we've got quite a few government departments and agencies, some reasonably large banking companies, consultancy companies, quite a decent chunk of experience as well. So it's quite a decent sort of group of participants. To actually analyze the data, we used an approach informed by grounded theory. So we transcribed the data, went through an initial line-by-line coding. As sort of codes and categories started to form, we started to do memoing and constant comparison, which we eventually grouped into categories and then eventually concepts. As well as the actual interview data, we wanted to capture sort of what are the current types of technical debt, as we wanted to relate these back to the sort of issues of legacy applications. So we went through literature and we found current technical debt types using the keywords on the screen there. So as to the actual experiences that we found, our participants had a sort of a mixed definition of legacy. There tended to be a divide between technical and non-technical. Technical were more concerned with the languages that were in use, the hardware, the software, as you might expect. The non-technical were more concerned with, does it support the business needs? Yes, no. If it doesn't, that's an issue. The sort of main concepts that came from the sort of analysis of the data were that they have fragmented applications. A significant amount of legacy is sort of inherited over time through company mergers, the merging of government departments and that sort of thing. Applications no longer represent organization's needs, which you might expect. Skills gap impacts ability to maintain and evolve. Again, legacy languages not in vogue anymore. Developers tend to want to use the latest and greatest technology, which causes obviously friction for companies that have old applications, and complex system architectures, which you might expect as well. So once we'd found these concepts or themes, we compared them with literature to see how it relates in terms of the symptoms and its sort of the impact in terms of current definitions of technical debt. So we sort of categorized these or classified these as follows. So on one that we didn't find in literature, which is what we've sort of proposed, which I'll discuss in a sec, is this idea of ecosystem debt. And this is a sort of new thing that we feel was missing. So these large-scale legacy applications, they to us represent a software ecosystem. So just to provide a sort of definition there on the right of what sort of a software ecosystem is, the interaction of a set of actors on top of a common technological platform that results in a number of software solutions and services. To us, there was a large number of applications that were heavily embedded within the sort of organizational culture, the processes, there was a sort of complex interdependency between them. These things evolved over a large period of time, and they became to sort of represent this sort of ecosystem within these companies. And what that meant was that you might have a legacy application that you've identified as, this is a candidate to remove or modify, but because it's dependent or depends on or is depended on by so many other applications, it suddenly becomes an issue, and you can't actually do anything about it. It's a cog in a much bigger mechanism that it's much harder to remove and modify. So to that end, we thought, well, this to us sort of maps to the idea of technical debt. It's a decision that was made in the past. We inherited some application, or we merged some departments, and then now further down the line, we're paying the price of that because we suddenly can't evolve, or we can't modify, or we can't retire our software. So we didn't find any sort of definition that sort of maps this nicely in literature. So we provided our own. We define the software systems and the systems they support, create a software ecosystem. Like any ecosystem, the impact on one aspect can influence others. If dependencies between software systems are not managed, future changes to the individual software system that make up these can become costly, if not impossible. So in summary, we provide insight into practitioner experiences while maintaining large-scale legacy. We classified our practitioner experience in terms of technical debt, and we introduced a new technical debt term, ecosystem debt. To us, it felt like the ecosystem aspects of our participants' legacy applications was the biggest sort of stumbling block for them to modernize and evolve their applications. Just to give an example, one participant mentioned having upwards of 600 applications in their sort of technology stack, or technology, not stack, but their sort of portfolio that was supporting tens of thousands of internal users. So as you can imagine, that's quite a challenge to have to manage and deal with, and obviously very expensive. And I think that's the end of my presentation. So any questions?
Okay, so thank you for your presentation. I do not see any question from our audience, so I will ask you some questions by myself. So actually, you talked about practitioners, that your main objective is to speak with practitioners that are managing issues with legacy software, actually. So in your opinion, so to have a kind of wrap up of your presentation, are there some possible technical guidelines that the practitioners can take by the research? So is there the possibility of gathering technical guidelines from the research about the tools and techniques that can be actually and actively used by practitioners in an actionable way to manage the legacy software and their technical debt?
Yeah, I think there probably is. I mean, we didn't really touch on tools in our sort of questioning, but that's something that's we probably will be following up on in the next sort of 6 months for my PhD. But for me, I felt like, and there is some existing research that touches on this, in that legacy researchers technical debt research and industry practitioners can learn from the sort of history of managing a legacy application, whereas we sort of take an alternate view, or the opposite view, that actually legacy application management and legacy research can sort of learn from technical debt research in terms of measuring technical debt and managing technical debt. And in our view, legacy applications are really just the accrual of a large amount of technical debt over a long period of time, and that if you can capture that state using sort of technical debt measurement tools and quality metrics and stuff, you have more insight into the state of your legacy application, the cost, how much would it cost to retire it, how much does it cost to maintain or evolve, and that because the technical debt has that gap, bridges that gap between sort of non-technical and technical, it gives developers a bit more of more tools in their sort of toolbox to go to their bosses and the CIO and CTO and say, hey, you know, we've got this legacy application. Yes, we know it works and it does the job. It's a cash cow, whatever. But ultimately, it's going to cost us this much in the future. It's slowing development time this much. You know, we can actually say with a measurable metric, say this is how much it's impacted us. And ideally, that would just sort of make decision makers say, okay, yeah, let's do something about this. And also, there's an element of prevention as well, where if you're aware of the impact of, for example, with the ecosystem that these sort of development applications, these application landscapes evolved into, if you're aware of the impact that will have later on, you can potentially nip it in the bud before it gets to the point where it becomes a massive issue, where it's hugely expensive and it almost becomes impossible to do. And in a lot of these cases, you know, there's high amounts of failure and they take a long time. There's a huge amount of cost associated with them. So for us, really, it's the legacy application sort of space can really borrow from sort of technical debt management and measurement. And I think it would be far more useful from a practitioner perspective to sort of think in those terms.
Okay. So, and you mentioned about, yes, you mentioned in your presentation and right now about the concept that you yourself defined about the ecosystem that, which it is a very interesting contribution actually. And also, have you already aimed at providing kind of measurable connection between code-based technical depths of the individual components to obtain a kind, I don't know, a kind of predictor or a kind of measure of the whole ecosystem depth? Do you already have some measurements for that, or are you working towards a kind of automated way of estimating the ecosystem depth?
Yeah, so for the sort of future research for my PhD study is this, there's essentially two phases followed from now. One is the tools and techniques that sort of developers are using who manage legacy to understand what they're actually doing. That's sort of at the coalface sort of situation. And then following on from that, we want to try and look at automated analysis and hopefully improve on sort of technical debt metrics, so measure it, refactor it, see how it's improved. And we have looked at how we can measure ecosystem debt. The initial idea was quite naively, well, if you take an aggregate of all the different applications, but we feel, you know, there's probably a compounding effect, you know, for every 2 or 3 applications you've got, increases it by 10-15% or whatever. So it's not something we've started to look at, but it's something we want to look at further down the line. What we'd like to be able to do is go back to these companies that we've interviewed in sort of the end of my PhD and be able to say, hey, let's try this out and see if we can measure their whole sort of system and say, well, here's the state of play for you, and allow them to make a more informed decision on what they need to do. You know, which applications can they retire, which ones can they maintain, and that sort of thing.
Okay, thank you. I have no more questions about your work. So thank you for your presentation and thank you for your interesting job. Goodbye.
Thank you.
Okay, so now we will move to a paper from the industry, and our next presenter will be Celine de Knop, which will present a work made by her, Johan Fabry, Kim Mensch, and Vadim Zaitsev. And the work is named Improving a Software Modernization Process by Differentiating Migration Logs. Okay, so welcome to the PROFES2020 conference, and please introduce us your work.
Hello everyone, thanks for welcoming me. I'm Celine de Knop and I'll be presenting our paper. So since I'm an industry paper, let's dive right in and present the company we work with, which is Rain Code Labs. They do many different things, but for this specific case, we will focus on their Pack-based migration project. First, let's talk about Pack-based. It's a tool that was developed in the 70s and that allowed developers to use macros and other higher order functions to create code. And that code was then translated to COBOL, which you might know. And it was quite popular from when it was created to actually even right now. But the thing is, the support was finished in 2015, which means that now it's more of a liability for those companies. Because as you can expect, generated code is not very maintainable, not very readable either. And since Packbase is a tool that is now aging and decaying, well, it's hard to maintain the code created by Packbase, and you can't really use Packbase anymore. So Raincode works to migrate such Packbase code into something else. On the schema there, you can see a summary of what they do. They take the code generated by Packbase and they refactor it using what they call transformation rules. You can see them as very small refactors that make the code just a tiny bit better, and they apply them over and over each after the other until none can be applied, and the code is then called migrated. This process outputs the COBOL code that's migrated and also some log that we will look at later. Very concretely, you get something like this. On the left part of your screen, you can see code that was generated by Packbase, and on the right side, the same code that was migrated by Raincode. So you can see that it's quite a bit better on the right side. Now, a very important thing to understand about this is that the generated COBOL is old and unmaintainable, but it also is part of the core business of the client. And those clients are quite big companies, usually banks or insurance company, even airlines. And this core business is really important. So to put the new migration code into production, the client needs to trust the migration process. And while all Raincode engineers have been at this for more than 15 years, they are pretty sure the rules are good, but the client, he needs to be sure himself. So the first step of such project is simply to run the migration on a few programs and then test the output. The client needs to make sure that it will be safe to put in production. Then the entire code base can be migrated and delivered to the client. Now that we have an idea of what's the migration process, let's talk about a small timing issue that arises. As we said, the code that's being migrated is part of the core business of the client, which means, well, he can't really afford to stop all development on all the code for the time of the migration. And we are talking, even if it is an automated process, more like 2 weeks than 2 hours. So what happens is Raincode gets sent a snapshot of the code at the time the project starts. And while they're working on migrating the code base, well, the client keeps developing. And by the time they are done migrating, there's a new version of the Packbase generated code. And those changes that were developed, well, the client wants them to be integrated. So how do we do that? Easy, we run the migration again. But now we have a different question. What changed between the two versions? That new version hasn't been tested. Can it be trusted? Is it safe for production? What changed? And why did it change? Raincode then performs a manual analysis to try to answer the client question. And to do this, they use diff and the log of the migration. Now, diff is a term widely used in computer science and actually the core of my PhD. It's an old technique based on an algorithm that was developed in the 70s. And on the left side of the screen, you can see an example of a diff. Here, it's just a screenshot from GitHub, which is a software that most of us know. And while it is so widely used, well, it hasn't evolved much. And most of the time, it doesn't suffice for the engineer because it gives output that are so large that they can't really read it all. And so they just kind of do it by instinct. Another thing is that it's really important for them to be time efficient when they do this manual analysis, because if they take too much time, well, there will just be a new version of the program and they'll have to do it again and turn infinite loop. So since they do it so quick and dirty, well, the client doesn't really receive full explanation, which means maybe he doesn't trust the full process. And that sometimes also leads to more time loss because, well, he will answer, but I need more details, and the raincode engineer can't really give those details to him. So that's where we come in our research project. We want to create tools to help raincode explain to their client where the code has or hasn't changed, how it has changed, and why it has changed, and even more, do that in an easy to understand format, both for the engineers and for the client. For this specific talk, we will focus on why it has changed, and on our future work, we will explore other options to explain where and how it has changed. Now, as I said earlier, we will look at the migration logs to do that, and we will base our work on a paper from Goldstein et al., which is called Experience Report Log-Based Behavioral Differencing. In their context, they were looking at the behavior of a network over time, and it's actually quite easy to translate it to our use case of a migration. The first step is to model the logs that you have, create an abstraction for them. And for this, we choose a finite state automaton, which is a graph, as you can see on the left side of the screen, with the nodes representing the different rules and the arrows between them representing the probability that we switch from one node to another. To do that, in our specific use case, we use an open source tool, which is called Synaptic, that you can find at the link there. The second step is easy. You simply use the algorithm that was defined in the paper to diff those two different models and present the result. On the left side, you can see the result that was presented from the paper. And on this slide, we can see the result that we have with our result and our migration. There's a few differences. First, we chose to go with color rather than shape, like the last time. And you can also see that there is no longer the labels on the screen, simply because we thought it was too cluttered. You can still access the label on the arrows simply by mousing over them. And finally, our use case was quite a bit bigger than the use case with network analysis. So we choose to fuse some of the nodes. The big gray circle that you can see are nodes that were fused, simply because there was no change in that part of the graph, and it's not interesting to look at a succession of nodes with no change. For the next step of our research, we will need to go through validation with raincode engineer. We want to show them the tool and ask their opinion. And we've just started that early, and they've said that it's understandable, but they want to have a more global view of the entire migration. What you just saw concerns only one file, and we want to give a view of all the files that were migrated. And for that, we plan to use probably small multiple visualization. To conclude, here we presented our concrete use case with raincode, and also our tool allowing to examine the evolution of the migration process. The current version is usable and open source if you want to try it sometime, and we will now be working on making the important information easy to find. Thank you for your attention. If you need to contact me, here's my email address, and I'll be now answering your questions.
Okay, thank you for your presentation. I have just, it is an interesting work which gives a different perspective on code migration and how to analyze and how to give a narrative of the code migration. And I have just a couple of curiosities about your work and about the way you use the code differencing. And so, first of all, have you considered about taking the possibility of taking advantage of other types of information, like, I don't know, using automated learning of the characteristics of the code of which you take the migration logs, or the possibility of using learnings of the changes upon the different migrations and the different releases, or code clones inside the code that may suggest that the same changes are made multiple times in order to obtain an easier extraction of the migration logs and an easier extraction of information from them.
Yeah, so we have considered lots of things, and I think all the things you said might be interesting to explore. We just had to start with something at some point. So
Yeah.
I think we will definitely come back to the COBOL itself later in my PhD. As for using clones to find the migration that happens often, it's interesting, but it's actually the exact opposite of what raincode engineers want. What they want is not what happens a lot, because what happens a lot is probably normal. What they want is what happens never, because that's an issue. So we will look into that next, probably either with clone or pattern mining and just take what's not the output of the patterns. So yeah, that will be what we will do next.
Okay, and in your opinion, what is is your approach completely generalizable for any kind of migration, and the applicability of log differencing can be indeed applied to other languages and other means of migration of code bases?
Well, to me, our tool is actually quite easy to apply to something else. You just have to have a model of your log. So this model can be generated with the tool I presented. And once you have those models, you can simply diff them. Now, will it give you interesting information? That will depend of the context. If you log smartly, let's say, and you actually need to see, okay, so this time this happens and not that, then it would be quite easy to use our approach to simply do that.
Okay. Okay, so I have no more questions, actually. Thank you for your presentation and for your interesting work. And thank you for having you with us. Goodbye.
Bye.
So our next presentation will be the presentation by Khaled Al-Sabag. It will be again a full paper. And the work has been conducted by Khaled Al-Sabag, Miroslav Saron, and Regina Hebig.
Hi.
Please forgive me if I misspell something. The name of the work is The Effect of Annotation Noise on Continuous Test Case Selection, a Controlled Experiment on Industrial Data. So welcome to PROFES2020, Khaled, and I leave the show to you.
Thank you very much. So welcome to this presentation, everyone. In today's presentation, I'm going to introduce you to a method for test case selection. This method was evaluated on industrial data sets. And I'm also going to talk to you about the results of an experiment that we conducted to examine the effect of one type of noise found in the data on the performance of the test case selection approach. I'll start by giving some context about continuous integration. What we see here in the diagram is a continuous integration pipeline for a main branch in a version control system with a number of builds denoted with those blue circles, where a build is a compilation of all the features that were pushed by developers to different branches and got truncated to the main branch. Once a build is created, we have a number of test cases that get executed to verify that the new changes did not adversely affect the behavior of the system under test. But the challenge in adopting continuous integration and continuous testing lies in the amount of time required to execute those test cases, particularly when the system grows in size and complexity, and the pool of tests grows as well. And this leaves the developer in an idle state waiting for the continuous integration system to provide feedback about whether their commits passed or failed the tests. So if we could analyze the code changes pushed by developers, then maybe, and predict which test cases will fail and which test cases will pass, then maybe we can reduce the size of those test suites that are run after a build is created, and only include test cases that will reveal failure or that will fail, and exclude tests that will pass from the suite. So our approach to address this problem of test case selection, or finding a subset of test cases that will identify a fault or will reveal failure, was to use a machine learning model to train that model on code changes and the relevant test execution results, in a hope that the model will be able to predict which lines in the code will trigger a test case failure and which lines will not. And this way, we hopefully can reduce the size of a test suite by only including those tests that will fail. So the method was called MeBots, which stands for Method Using Bag of Words. And the first step in the method, we start by collecting code changes from history logs in version control system and the relevant test execution results from data stores. And once we have this data, we feed this data into a feature extraction algorithm to make the conversion from a textual format of the code into numerical format or feature vectors. And then we feed those feature vectors into a supervised machine learning model to classify lines of code as whether they will trigger a failure or not. Let me walk you through a small example to illustrate each step in the method. Again, we have a main branch with 4 builds here, and we have 2 test cases that will run on 2 builds. So when we start by collecting code changes, what we do is we extract code changes made between 2 consecutive pairs of revisions. So suppose this code fragment belonged to revision 1, and later was modified to become something like this. So what we extract are all the lines that were added from revision 1 to revision 2. And once we do that, as soon as we do that, we randomly select a test case whose verdict changed from revision 1 to revision 2, and use the execution result of that test case to label each line of code in the extracted code changes. And in this example, we picked the verdict failed for test case 1, and we used the value of 0 to label each line of code as in failing test. Now, the second step of the method, as I said, is to convert the code that we extracted into numerical format, feature vectors. And for that, we use the bag of word approach, which basically counts the frequency of occurrences of each token in each line to create those feature vectors. Now that we've generated the feature vectors, we're ready to feed those vectors into a classifier. But one thing we need to be cautious about is the quality of the data at hand. Particularly, we need to ensure that the data comes with as little noise as possible, where noise can be anything that obstructs the classification accuracy or the performance of a model. Examples of such noisy observations could be having duplicate entries that are labeled with different class values, or could be using a measurement tool that produces erroneous measurements in class and attributes. Now, suppose that we have the following 2 statements, printf from C language, and those statements were converted into feature vectors using the bag of word approach. They will have the exact same representations, but in this example, they were given a different label or different class value. We refer to those entries found in dataset as contradictory entries because they're exactly the same, but they have different class values. And we calculate the ratio of those entries relative to the total number of entries and refer to this noise as class noise or annotation noise. So the goal of this study was actually to examine the effect of having class noise in the data on the predictive performance of the model for predicting test case verdicts or for test case selection. And for that, we conducted an experiment, a controlled experiment, where we had the one independent variable, which was class noise. And it was studied for an effect on 4 dependent variables, precision recall, F-score, and Matthew correlation coefficient. And to support the investigation of the goal, we needed to have a control group or a baseline group that comes with 0% class noise in order to be able to compare the performance scores of the model that is trained on data with 0% class noise against a model or performance scores for a model that is trained on data with variation level of noise. And in this experiment, we used 6 variation of class noise, 10, 20, 30, 40, 50, and 60%. As to the data, we worked with 246,000 lines of code and 82 test executions belonging to 12 test cases for a software telecommunication company in Sweden and for a software program written in the C language. Now I'll explain the algorithm for creating this control group with 0% noise ratio. And the algorithm starts by picking a random vector from both of the classes, and we refer to those vectors as baseline vectors. So we pick 2 vectors from each of the classes, And then the next step, we compare this baseline vector against all the remaining vectors in the relevant class, and we compare them for the similarity in orientation or cosine similarity. And given a threshold of 95%, if they were similar in their orientation in more than 95%, then we add the compared with vector to the control group. Otherwise, we discard it. So the control group had a size of 9,330 lines after applying this algorithm. As soon as we derived the control group, we derived experimental subjects that we'll see noise into. And for that, we use certified cross-validation with k equals 15. So we have 15 subjects, each of which came with 622 observations. Just taking the time. Yeah, and for evaluating the performance or for evaluating the effect of class noise, we used a random forest model where we fed the experimental subjects at each noise level and recorded the precision recall F-score and MCC scores for that. And the results told us that there was a downward trend in performance among the 4 performance measures, precision recall, F-score, and MCC, when we went up in the noise ratio that we seeded. We also ran a statistical test to just double check that these values are statistically significant, and we did find significance in all of the performance scores apart from the recall, which we found that it was significant when the noise ratio exceeded 30%. What the results also told us from a practical perspective is that testers need to avoid using the prediction model when the noise exceeds 30% unless they can handle this noise before using it for training. Otherwise, testers do not need to bother when the noise is less than 10% in the data. So in conclusion, we found that yes, class noise has a detrimental effect on the predictive performance of a model for test case selection. We did provide testers with a formula that they can use to calculate the noise ratio in the data, and so that they can decide on which strategy to use for handling the noise. And as future work, we would like to study the effects of attribute noise on the prediction of test case verdicts. Thank you very much.
Okay, so thank you for your presentation. I have a couple of questions about your work. So, first of all, have you considered you have used the bag of words for the classification? So, have you considered to use other language models instead of bag of words, or other feature vectors instead of the one generated by bag of words, and reason about the possible influences that this kind of input can have on the system, maybe having an impact also in the noise, in the class noise?
Yeah, we did actually. We also tried with word embeddings, where with word embeddings you also capture the semantic and not just the syntax in the code. But the problem, I think, and the challenge was that the bag of word approach and even the word embedding, they do not generate distinct vectors. So if you have x equals x plus 1 or y equals y plus 1, then these two also would have the same representation when using the bag of words. So we tried to test our own algorithm for that, where we guarantee that there is distinct generation of vectors. But I mean, our experiment showed that the bag of word approach outperformed the rest, the other two, the word embedding and the other one.
Okay, and from a kind of of a utilitarian point of view, so actually there is a kind of risk given by this. You pinpoint the fact that there is a risk given by this class noise problem to the usage of machine learning by companies and practitioners in actually predicting the test cases behavior and their failures. So in your opinion, there is a point at which this class noise issues may make the usage of machine learning based predictions unuseful for practitioners, may render this kind of practice not convenient for the testers.
Yeah, I think this is worth investigating. I mean, the time it takes for processing the data, or like looking at how much time it will take to clean the data. If you want to achieve higher prediction of which test cases will fail and which ones not to include in the test suite. So it could be the case, but I think, like from my experience, cleaning class noise from the data is not of a big hassle. So as soon as you can detect those contradictory entries, then you can handle those by either relabeling or either removing those from the data.
Okay. So in your opinion, you can at least estimate that the quantification of the class noise is not hampering the possible adoption of these issues of this type of predicting the test case failures. There is the possibility anyway of working around it.
Yep.
Okay. Okay. So I have no more question, and I see that there are no questions in the comments. So thank you for your presentation and for your work.
Thank you very much.
Goodbye.
Bye-bye.
So we are a couple of minutes ahead of time. I hope that the next presenter is already here. So our next presenter is Steve Council, which will present us the last paper of this test and evolution session. The paper is a short paper and will tell us about the work by Steve himself and Stephen Swift, Mahir Arzoki, and Giuseppe De Stefanis. The title of the work, as you can see from the first slide, is On Clones and Comments in Production and Test Classes, an Empirical Study. So welcome, Steve, to PROFES2020, and I leave the words to you for the presentation of your work.
Okay, thank you, Ricardo, for that introduction. So this is some work I've been doing with some colleagues at Brunel University, and it's founded on the belief from a workshop which I attended a reasonably long time ago, where project managers were asked to identify the things that they would stop developers doing if they possibly could. And one of those things was copying and pasting. And ever since then, I thought, well, maybe there's something going on here with clones, and I've always had an interest in comments and the role that comments plays in these two types of classes specifically. So that's the basis of the empirical study which I'm going to present. So it's fair to say that we've looked at, in the empirical world, we've looked at many studies over the past 40 or so years, including concepts such as coupling, cohesion, complexity, and size. And in a sense, they've all contributed to our understanding of how systems evolve and the relationship between those factors, and those features and faults. But one thing we haven't done that much is to look at this distinction and the relationship of those factors with production and test code split individually and isolating those types of code. So many open questions remain in this relationship between production and test code with respect to these factors. What I'd really like to get to grips with is test code treated differently by developers than production code? Is there something going on here, basically? So what we did is we explored the differences between test and production code from three perspectives. Firstly, the number of clones in each of those types of class, the number of comments in each type of those two types of class, and thirdly, the maintainability aspects of each of those types of class. The general hypothesis running through this work, I guess, is that we believe that test classes are treated very differently by developers to production classes. So if we were to generate hypotheses for our work, we'd say that we'd see more clones in test classes because we believe that clones are not necessarily a good thing, fewer comments in test classes, and that test classes will be harder to maintain, all with respect to production classes. So what do? We looked at 6 open source systems, and you can see there's a fairly broad range of production and test classes in each. Obviously, nothing we can do about that. It's a threat to validity, the different numbers of production and test classes, but that's the way it is. So what else we did? Well, we collected 3 metrics in a sense. Firstly was obviously the number of clones, and there are various definitions of clones around. We took our definition of clones to be an identical code fragment, except where there are variations in white space, layout, and comments. But we accept there are other definitions of clones. Comment density, which is calculated by dividing the total number of comments by the number of lines of code to give you a feel for the how roughly, approximately how frequent comments are in the class. And a comment density of 0.5 will tell us that half the lines in that class are comments. And lastly, something called the RMI, the Relative Maintainability Index of Hegelus. And what this metric does is reflects a level of maintainability in the class when compared with other classes in the system. It's different to many of the other metrics which try to measure maintainability because it uses a dynamic threshold from a benchmark database instead of a fixed formula to calculate. So in a sense, we think it's perhaps a little bit more credible, but obviously that's something that's open as well, how credible this metric is. But we think it's a reasonable metric. So some summary data for clone data. So what we have is production data on the left-hand side, test data on the right-hand side, and you'll see that there is a clear trend for clones to be far more frequent in test classes than production classes. If you look at the maximum and the means for each of those systems, you'll see that they exceed the production number of clones in pretty much every single case. I think there's only one case where that's not true. So in the 6 systems, there was huge, I mean, look at the value differences in means and between the different systems, you'll see there's a huge variation in clones in test classes compared with production classes. Comment density. So we believe the table shows the same as the previous table, the production classes, the test classes, and there were far fewer comments in test classes than in production classes. So you'll see there the mean, the medians, all very, very much smaller than the corresponding production class values. We believe comments are a good thing generally. There are some people who say it's perhaps not a particularly brilliant thing, especially if there are too many of them, but that's an open argument. But generally speaking, for the systems we looked at, there were far fewer comments in test classes than in production classes, given by this comment density metric. If we look at the range of comment density, when we compare production versus test classes, production here is in the gold bars, test classes in the blue bars, we'll see that the comment density in values in the range 0 to 0.1, test classes had a higher frequency of comments, but at higher levels, you'll see that production classes had a much higher level of comments. And you can see that from the graph as you go along towards the high levels, there are far more comments in production classes. Finally, maintainability. So maintainability given by this metric, the RMI metric. So what we did is we correlated clones and maintainability. And what you have on the left-hand side there is the production values. And again, on the right-hand side, the test values for the correlation between clones and this metric, number of clones in the metric. You'll see that there's negative correlations, but the interesting and most relevant thing here is that the negative correlations for test classes are significantly higher than those for production classes. So what does that tell us? Well, it suggests that the higher number of clones you have in a class, the lower the level of maintainability there is in that class, given by this RMI metric. So if we were to make a tentative conclusion, we would say that test classes get relatively low support and less well maintained and maintainable than production classes. That's a typo, sorry. And the presence of clones may indeed make the job of the developer much more difficult, and that's borne out a little bit by the data. So threat stability for our study, well, obviously there's quite a few threats. We only use 6 systems in our study. We'd want to use more ideally, but this is, as a tentative preliminary study that we used the 6 we had. We're assuming that the RMI index metric is actually a good measure of capturing maintainability. Some people would say it's not, but we believe it does capture maintainability because it's based on this threshold analysis. We also think maybe perhaps the use of our definition of clone might be subject to criticism. I mean, there are many other variations of definition of clone, and in fact, they might have a more sinister effect on maintainability than we've shown. But that's for future work. So our conclusions were that test classes are given less attention by developers, and that firstly, they'd have more clones than production classes. Secondly, they'd have fewer comments. And thirdly, that they would be more difficult to maintain. And we adopted that stance because we believe that developers care less about test classes. They're almost like they're not the front-facing part of a system, so they don't upkeep them as well as they do production classes. And in effect, test classes are treated like second-class citizens as a result. And as a result, developers don't tend to invest as much time in the upkeep of test classes as they do production classes and on basic housekeeping. And our results have reflected those initial suppositions. So we found some evidence that was the case, that test classes are generally perceived, and in this case from the data, have a negative sort of a profile compared with production classes. I think that's it. So thank you for listening, and I'll stop sharing. Thank you.
Okay, thank you for your very interesting presentation. And actually, by working in the same area, I know how deeply rooted is this problem that the test code is not so kept into the same attention as production code by test developers. So it is a place where you stockpile a lot of problems and maintainability issues. So it was an interesting contribution from your side. One of my curiosity was about you measured the maintainability of the production and of the test code, but did you the way you measure the maintainability is that you measure the all maintainability of all the production code, or you average it for all the production code, and you did the same for the test code for each of the tools?
Okay, so the RMI it's a class-based metric, so it was given on a class-based basis. So we just correlated the RMI metric versus for production classes versus the RMI value for test classes, and generated those correlations on the slide that I think I showed for the outputs of doing that. So yeah, the RMI gives you a class-based value which reflects its maintainability or otherwise. So that's what we were going by, Ricardo. So yeah, and I hold my hands up. It may not be the best metric in the world, but there's only by empirically studying this stuff that we're going to find out whether it is or not a value, and whether it gets take up or that. So yeah, it's a class-based metric.
Yeah, and because actually one of the issues that I faced was to actually find the right pieces of code in the production code that are tested by the individual test methods, and this is a bit of an issue to understand the right correlation between maintainability. Did you explore this possibility, or do you have suggestions about how to pinpoint the right places that are tested by a test method in the production code?
I didn't drill down into the actual code to that extent, Ricardo. There's also we also got a threat to validity, which is that different testers, different maintainers all might treat test classes and production classes in different ways. So you have that sort of mix of some people might adhere to guidelines, some people might not. So there's lots of things we could explore. There's lots of threats which might have influenced the results. I couldn't say, we didn't drill down to that extent, no, but I can see how that might be useful as a means for future work, for sure. Yeah, but no, not directly. I can't answer your question, I'm afraid. Is what I'm saying. Yeah.
Yeah, I know it was just kind of because there are, as you say, there are many different dimensions that you can explore. There is the time-related dimension, for instance, the correlation between the actual places. So it was just a curiosity about the possible facets that you are exploring, and I was curious if you were already exploring them, because your work was quite was very good in the description of the problem.
Okay, it's interesting because when I mentioned this problem to different audiences, so we've had some stuff done, we did some stuff a while back, you'll get different reactions. Some people will say there's a problem, and other people will totally deny that there is a problem. I guess it's all down to your own view, your own perspective, and your own, the code you work on yourself. But I was surprised that it's not a widely acknowledged problem. Certainly, I get differing opinions depending on who I'm talking to. So that's interesting alone. And that inspired me to do the work, because if there's a disagreement between something, then the only way we can actually try and improve that situation is to try and do some empirical work on it. So that's basically why I get your point, Ricardo. That's a good point. Thank you.
Yeah, it definitely is, like you say, it is not well, a well-renowned problem among practitioners and researchers themselves, which is a stranger from a certain point of view. So
I'm hoping no one will actually listen. So because I still want to do research, and if everyone else goes away and does the research, Ricardo, I'll have no work to do.
So I see that there are no comments, no questions in the comment section about this intervention. I have no more questions by myself. So thank you for your contribution and for your work. Goodbye. So we are a couple of minutes ahead of time. We have no more presentations in this session. So the next session will be about data science and analytics, and it will start at 4 p.m. So you will have a 14 minutes break starting from now, and let's see you later again on this platform.
Hello, everyone. Welcome to the third session of the PROFES2020 conference about data science and analytics. My name is Silverio Martinez Fernandez. I'm working in the Technical University of Catalonia in Barcelona. Okay, so in this session, we are going to have 5 very exciting talks from 3 different countries, Finland, Germany, and Sweden, and also with papers both from industry and different universities. So I would like just to remind you a couple of things. One of them is that you can download the proceedings in the link that we will provide in the chat and that we have also commented in previous sessions. And also that you can make many questions through our YouTube chat, and we can select a few of them, and then the authors will have the chance to reply to these questions. Okay, so just for authors, I would like to point that they have 10 minutes for the presentation and 5 for the questions. And I would like to start with the first presentation. So let me introduce our first presenter, who is Theodor Fredriksson from Chalmers University of Technology in Gothenburg, Sweden. And he is going to present their work about data labeling and empirical overview of industrial challenges and mitigation strategies. So please.
Thank you for the introduction. I'll start by introducing the topic. So I'm going to talk about data labeling for machine learning. And so current research estimates that over 80% of the engineering tasks in machine learning projects concern data preparation and labeling of said data. And in fact, the third-party data labeling is expected to triple by 2024. And this massive effort spent on data labeling has to be done because in industry, data sets are often incomplete in the sense that instances are missing labels and or are of poor quality. And labels of sufficient quality is essential as the performance of a model is directly influenced by the quality of the training data. So a common strategy today is crowdsourcing. But it has crowdsourcing has proven to be very common strategy, for example, computer vision and natural language processing. However, it has several limitations for other industrial applications, such as allowing unknown third-party access to company data, having a lack of people with an in-depth understanding of the problems, or not having the business to create quality labels. In-house labeling, on the other hand, can be half as expensive while providing higher quality, and due to these factors, companies still perform in-house labeling. And despite the large body of research on crowdsourcing and machine learning systems that can overcome different label quality problems, to the best of our knowledge, there was no research that investigated the challenges faced and strategies adopted by data scientists and human labelers in the labeling process of company-specific applications. So the contribution of this paper is twofold. First, we identify the key challenges that these companies experience concerning labeling data. And secondly, we present an overview of the mitigation strategies that companies employ regularly or potential solutions to address these challenges. So we have answered 2 research questions. What are the key challenges that practitioners face in the process of labeling data? And what are the mitigation strategies that practitioners use to overcome these challenges? So our case study was conducted in collaboration with 2 companies. And the first company is a worldwide telecommunications provider and one of the leading providers in information and communications technology. And company B is a company that specializes in labeling, and they have developed an annotation platform to provide the autonomous vehicles industry with labeled training data. And so we collected our data during 2 phases. The first phase is based on an internship that was done from November 2019 to February 2020, in which I spent time at the company's ACE office 2-3 days a week. And we collected the data from 2 data scientists, observing how they were working with machine learning and how they deal with data where labels are missing, as well as we looked at some data sets. And we held discussions with each of the data scientists working with each particular data set to collect data regarding the origin of the data, what they wish to use it for in the future, and how often it's updated. And then we used software like Python to investigate the distribution of labels and to see if there was any correlation structure like cluster structures and so on. And then phase 2 was a validation phase. So after we identified the challenges from phase 1, we held both internal and external confirmation interviews to validate if the previous phases were general. And we had 4 participants from company A and 1 participant from company B. And the company A had several data scientists, but we only included the data scientists that had issues with labeling. And then we interviewed them separately for about 25 to 55 minutes. And we asked questions such as, what is the purpose of the labels? How do you get the annotated data? How do you assess the quality of data and so on? So we had several, during phase 1, we could categorize the problems in 4 different, or how many, 7 different categories. So the first problem was just that was just a lack of systematic approach to labeling data for specific features. So it was very clear that automated labeling processes were needed, and the scientists working at company had all kinds of problems, and they had no idea to how to approach the problem. And the second problem was unclear responsibility for labeling. So the data scientists have no time to label the instances manually. The stakeholders can label this, but they don't want to do it either, and thus it's left to the data scientist anyway to do it. Third problem is noisy label. So participant 1, for example, he had a small subset of his data that was labeled, but these labels came from some experiments that they conducted in a lab. And the problem here would be that some of the data, some of the true and the true data was discrete, while the generated data was discrete and the real data was continuous. There was a problem there with features. So participant 2 worked on a data set where the column of interest, for example, had 2 classes, yes and no. And the yes was based on 2 errors, for example, but the so error 1 and 2, but we were only interested in the yes based on error 1. And if the yes was based on error 2, then it should be relabeled as a no. But the problem was that you didn't know beforehand if the yes was based on error 1 or 2. So, and the fourth problem was difficulty to find a correlation between the labels and features. So for one of the datasets, for example, a cluster analysis revealed that there was no particular cluster structure for the labels, so it was hard to distinguish between them. The 5th problem was skewed label distributions. So the label distribution for both datasets were highly skewed, meaning that we have many more instances of one label than the other, and this can be very problematic when you do machine learning. And the 6th problem was time dependence, and this would refer to the data that participant 2 had, in which some of the no instances would be changed into yes later on, and so on. So that basically the labels could change over time. And then the 7th issue was difficulty to predict future uses for datasets. So the purpose of the labels in both datasets that we looked at was to predict new labels for future instances provided by the stakeholders on an irregular basis. But for participant 1, the labels might be used for other purposes later, but they had no current plans on how to use the label for different machine learning purposes. So then we had the results from phase 2, and they can also be divided into categories. So first we had the label distribution issue. So there were several different problems. So one participant had the data that had an unknown label distribution and needs to come up with the labels himself. And participant 1 to 3 all had skewed label distributions. And if it's skewed, so if a dataset has a skewed label distribution, then the machine learning model will overfit. And this would mean that if you have a binary classification problem, for example, where 80% of the labels has class A and 20% has class B, then the model might predict A most of the time, even if the actual case is labeled as B. And then we had multiple task-related problems. So participants 1, 2, and 3 say that for now, the only purpose of their labels is to find labels for new data, but the chances are that it will be used for something else later on. Participant 4 does not use its labels for machine learning purposes, but other practical reasons. And if you don't plan ahead and only train a model concerning one task, then if you need to use the labels for something else later, you will have to relabel these instances for new tasks. And then third, they had the annotation problem. So the problem here is that the data scientists are often tasked to do the labeling on their own. Even if the data scientists get instances from stakeholders, the amount of labels is often of insufficient quality or quality. So participant 1 has some label data that comes from laboratory experiments. However, these labels are only used to help label new instances to be labeled manually. Participant 2 has its label coming from stakeholders, but these instances need to be relabeled since they are noisy. And participant 4 defines all labels by himself and does not consult stakeholders at all. And then the fourth issue was the data reuse. And participant 3 had problems with reusing a model. First, the data was labeled into two classes, yes and no, and later the yes category would be divided into two subcategories, let's say yes A and yes B. And when running the model on this new data, it would predict yes, all the yeses as a new no suddenly, and the participant 3 had no idea how to why this happened. So from talking to company B, we found some other interesting stuff. So participant company B had, for example, earlier experience with automatic labeling, and they had done research on it for 7 years. And they also use crowdsourcing to label their data. And they also said that they use active learning to reduce the labeling time about 100 times. And the main problem they have is to evaluate the quality of the labels and access the human annotators' quality. And the main fact that they found that was interesting was that there was a big correlation between automation and quality. So the more automation you had, the worse quality you got from the data. And then, so machine learning models that you can use for data labeling are, for example, active learning, where you query instances by informative and allow an oracle to use them. And then you have semi-supervised learning, where you can learn using less data. And then we had some practical consideration for the active learning, for example, data exploration to determine which algorithm is the best, alternate query types, multitask active learning, data reuse, an unknown model class, unreliable oracles, skewed label distributions, relabeling cost and cost reduction, and stopping criteria. And based on these, we could basically define challenges and mitigation. We could define challenges based on the data that we got, and then we could also formulate mitigating strategies from these practical considerations that we see here. I think we're out of time.
Okay, thank you, Theodore, for your presentation. So now we have a bit of time for questions. So I remind everyone you can write your questions in the YouTube chat. In the meantime, I saw quite interesting applying active learning to reduce the time for labeling. So I would like that you put an example and elaborate on this activity.
Sorry?
So you commented that the company was using active learning to reduce the time for labeling?
Yes.
Yeah. So could you put an example of this?
So active learning is when you, so in traditional learning, like passive learning, you would just randomly choose which instances to label, and you would train your model on this.
Yeah. So how much could they improve the time for data labeling? With
how much
yeah.
I don't know exactly, but they said about 200 times it would reduce the labeling because instead of labeling all of the instances, they could just label the ones of relevance.
Okay, so I see one question from Antonio Vetro. So he says, data labeling is often outsourced to workers who perform myriad of microtasks in exchange for very low salaries. Could quality issues be also related to such work conditions?
I think it's probably related to this as well, of course. I have not done any research on crowdsourcing itself. none of the companies the company A, for example, that I was with, they didn't use crowdsourcing at all. But I think it might be correlated to that. But we are actually planning to write a paper about crowdsourcing as well, and perform interviews perform a survey with laborers on Mechanical Turk.
Okay, so thank you again for your nice presentation and also for the questions, Antonio. So let's go for the second presentation of today, which is data pipeline management in practice, challenges and opportunities. And the presenter will be Aishwarya Raj Munapi from Chalmers University of Technology in Gothenburg, Sweden. So please, go ahead.
Hi, Silverio. Thanks for the introduction. So hi, everyone. My name is Aishwarya, and this is our paper on data pipeline management in practice. And we were analyzing the challenges and opportunities of data pipeline management. So this is a paper I wrote together with Jan Bosch and Helena Holmström-Olsen, and I'm from Chalmers University of Technology. So before diving into the results, let's have an introduction about what are data pipelines. So data pipelines are nothing but complex chain of interconnected activities that starts with a data source and ends in a data sink. And it has several benefits, like it can process data from multiple assorted devices with minimal human intervention. It can accelerate the data lifecycle activities, thereby enhancing the productivity in data-driven enterprises. It enables traceability, fault tolerance, and reduce human errors through maximizing automation, thereby producing high-quality data. However, there are certain challenges such as data quality issues, infrastructure maintenance problems, and organizational barriers. So let's see the details of what these challenges and opportunities are. And the research methodology that we have adopted is an exploratory case study. And our objective was to identify the key challenges and benefits associated with implementation and use of data pipelines at industry level. For qualitative data collection, we use semi-structured interviews, and we interviewed 20 industrial experts from 3 case companies, and we transcribed their the interview recordings, and we selected 15 such interview transcripts for this study. And we also conducted a validation study using follow-up meetings, and also we presented our results at the respective case companies and collected their feedback, and we updated our results accordingly. So as told in the previous slide, we have selected 3 case companies, and we have named it as A, B, and C. And we selected 5 use cases from these 3 case companies. So the naming convention here we used is that the first part indicates the name of the company, and the second part indicates the number of data pipeline. So which means that, for instance, if you take A1, A is the company, and 1 indicates it is the first data pipeline that we have considered in the study. So yeah, these are the 5 data pipelines we have considered. So A1 is a data collection pipeline from company A, A2 is a data governance pipeline, A3 is a data pipeline for machine learning applications, B1 is a data collection pipeline. Again, it's a data collection pipeline, but it is different from the data collection pipeline in case company A, because this data collection pipeline was collecting the data from 3 categories of sources. And C1 was a data quality analysis pipeline, and company C was dependent on company B for getting their data. Okay, so we have categorized the challenges into 3. They are infrastructure challenges, organizational challenges, as well as data quality challenges. So infrastructure challenges include integrating new data sources, and the second one is data pipeline scalability, which is of course related to integrating new data sources, because whenever the number of data sources increases, the data pipeline has to manage the volume of the data from the new data source, and also sometimes the data type from sometimes the data generated by the new data source will be completely different from the existing data type, so that the data pipeline has to adapt to this new data source. And also it has to scale. So those were some of the challenges there. And also increased number of nodes and connectors in upstream was the third challenge that we identified. Because every time when a practitioner is designing the data pipeline, what he does is that he or she will try to try to atomize the activities so that the number of nodes and connectors in upstream will get increased. And the fourth one is that a trade-off between data pipeline complexity and robustness. So we all know that for a robust data pipeline, we would need two essential components called fault tolerance and mitigation strategies. So, but whenever we have these fault tolerance and mitigation strategies implemented at each stage of the data pipeline, the complexity of the data pipeline increases, so that there is a trade-off between this data pipeline complexity and robustness, and we have to find the right balance between this data pipeline complexity and robustness. And the fifth challenge we have identified in this infrastructure challenges is repeated alarms. That is, whenever a fault is detected, mitigation strategy is invoked, and as a default mitigation strategy, we have something called sending alarms to the to the respective team, or to the practitioner, or to the data pipeline owner. So what happens is that sometimes for some faults, it might take some time to fix it. So in the meantime, this practitioner or the data pipeline owner will be continuously getting the alarms for the same problem. And sometimes what happens is that the new alarms will get submerged in this repeated alarms, and they will completely lose it, which is not good. So that was also pointed as a major infrastructure challenge. And the second category is organizational challenges. So in organizational challenges, dependency on other organizations is a problem. So what happens is that one part of the data pipeline will be completely aware of what is happening on the other side of the data pipeline. So for instance, in our case, the company B and company C are related to each other, or at least dependent on, company C is dependent on company B. So whenever some sort of organizational restructuring or something is happening at company B, company C will be automatically affected. So, and the second one is lack of communication between teams. So due to this lack of communication between teams, each team will have their own data pipeline, and as a result, number of steps are repeated, and sometimes even they'll store the data, same data multiple times, causing redundant data storage. And the third one is increased responsibility of data pipeline owner. So I have already mentioned that before, like the data pipeline owner who is responsible for the entire data pipeline, he or she is completely responsible for this, for the data pipeline. And when something happens, this data pipeline owner will be completely exhausted with messages and alarms and whatnot. So that was the, so as a result, nobody wants to be a data pipeline owner. Yeah, that was at least a comment we got when we did this interview study. And DataOps DevOps collaboration is another challenge, organizational challenge, because the practitioners who practice this DevOps, they are really interested in learning new tools and technology, but the data practitioners are not that much interested in learning new tools. So that the collaboration between these two is a bit difficult. And third category is data quality challenges. Here we have three called missing data files, operational errors, and logical changes. So missing data files is nothing but when the data file is transferred from one node to another, then there is a higher probability of losing it in between. And many of the practitioners whom we interviewed have identified this error and or this challenge. And the second one is operational errors, so which is a result of the human errors. So sometimes we cannot completely make our data pipeline automatic. So what happens is that human involvement will become necessary there. Then as a result of these human errors, operational errors can happen. And the third one is logical changes, like sometimes when this data drift or data shift is happening, the distribution of data will be completely changed. As a result, the business logic that is implemented in the data pipeline also needs to be updated. So that was a major challenge, which was identified by, I think, 13 practitioners. Okay, and here are the opportunities. So we have also analyzed the opportunities or benefits that we can gain from these data pipelines. So the first one is that it can accelerate the data lifecycle activities as it is completely automated, and we can standardize the data workflow so that everybody in the organization will be aware of what is happening in the data pipeline and what are stages it has and how the data management is happening. And the third one is improved data analytics and machine learning models, because the data is available in right quality in right time with the implementation of data pipelines, and data sharing between teams is enhanced, and it is a critical element for data ops. So data ops is a process-oriented approach which merges two data pipelines called the innovation data pipeline and the value pipeline. So value pipeline is nothing but a data pipeline that extracts insights or value from the data that is collected. And innovation pipeline is something that injects new ideas to this data pipeline. So for implementing data ops, we need to have the data pipelines as an essential element. And it can solve data accessibility challenges. It can save time and effort of the human resources, because most of the stages will be automated, so that the time and effort of human resources can be saved. It improves the traceability of the data workflow, as we have this fault tolerance mechanism, and also as the activities are atomic in nature, it's very easy to identify where the fault has occurred. And it supports heterogeneous data sources. These are the opportunities that we have identified, and this is a consolidated view of the challenges and opportunities. So as I told you before, there are infrastructure, organization, data quality challenges, and these are the opportunities that I have explained before. And coming to conclusions, data pipeline is a critical element that can also support a data ops culture in the organizations. The factor inhibiting data pipeline adoption were mostly concerned with the human aspects. So if we can make it data pipeline completely automated, then it will be very beneficial for the industry. But there are certain domains that cannot adopt it, or certain use cases will not be able to adopt this completely automated data pipeline, because for instance, if you take a case of data labeling that comes as a stage in the data pipeline, what happens is that the data pipeline will not, we actually cannot completely automate this data labeling stage, and thus the data pipeline will not be completely automated. So there we need some sort of human intervention. So these are the conclusions that we have arrived. And yes, otherwise, thank you all for your kind attention. And if you have any questions, please feel free to ask.
Okay, so thank you, Aishwarya, for the presentation. So as you said, time for questions. Remember, you can ask for a few questions in the YouTube chat in the meantime. So I was interested into knowing about this role of the data management pipeline owner that you mentioned in the changes. You made the study in 5 companies. Was this did the 5 companies have this data management owner?
Actually, it was 3 companies, A, B, and C, but all of them had something. Yeah, they have. Okay. There are 5 use cases from 3 case companies. So for all these 3 case companies, they have someone in the role of data pipeline owner. But for some companies, they call that person as data pipeline owner. But in 2 other companies, they have another name, but it is something company specific, so that I don't want to disclose that. But yes, the thing that they are doing is basically the same, so that we can call them as data pipeline owner, because they are responsible for handling all these faults whenever it is detected, and also whenever someone is finding problems with the data pipeline, or if the data product delivered by the data pipeline is not of good quality, this particular person is responsible for handling that.
Okay, and also you mentioned quite a few opportunities.
Yes.
And I would like to know your opinion if you would prioritize them, or even if you are going to work within the next months or years in some of them.
I think the opportunities are quite many, and challenges if you weight challenges and the opportunities, I would say that opportunities are more. So that I would say that if I am given an option, of course I'll implement data pipelines in the industry that I'm working on.
Okay, so thank you again. Very nice presentation. And I think we don't have any more questions. So we can go for the third presentation, which is demystifying data science projects, a look on the people and process of data science today. So here we have a company, Tieto Every, And it will be, we will see a video from Timo Ao from Tampere in Finland in a multidisciplinary a group of researchers working together from Tampere and Helsinki. So yeah, even if the session is recorded, the presentation is recorded, we will have the chance to ask to the author some live questions. So please, video.
Cecil Yaman from KPMG and Tommi Mikkonen from University of Helsinki. My personal motivation on the topic came from my background. I've been working after research. I have been working on consultants companies and also in in-house teams on cloud data, big data, data engineering and data science projects. And specifically data science consultants projects have been very difficult to actually make successful. And then this question, are we just doing something wrong or is there something really problematic actually in data science? Ross in 2019 actually had an opinion or wrote about the topic that for all data science enterprises are hiring, there's really very little so for it. Many data analytics projects fail to go into production. So the same could be more generally related, but data scientists do not necessarily succeed so often as other one. Our research questions related to this one were: what is the typical process flow of data science projects? And also what kind of people are part of that one. And what was actually new in our research was that we do already have prior work on data science compared to software development, especially in specific companies. Specifically, Microsoft has done a lot of work on this one, thanks to them. And also we had studies on data science projects, workflows and project types, or separate research on team structure. However, we feel like all these are related and we would like to combine them across multiple companies, specifically consultants companies here. We know from prior work, we know that there are some typical problems with data science projects, schedule and budget estimation, which are something that software development projects had a few decades ago, specifically more of these. Also change management, which means that if you are doing some changes, they easily escalate into larger changes everywhere in the product. However, also we know at least few years ago that often only a small portion of these machine learning systems, at least, are actually machine learning. The rest is something else. Well, it's important to remember that there are multiple kinds of projects that are thought to be data science, research type projects, also in production projects actually. So what we did, we had semi-structured interviews with 6 data scientists from small to mid-sized companies, and all of them were external consultancy companies, so no in-house. And Finnish companies, every data scientist was from different company. We did thematical analysis on those. We got 3 higher-level teams and 13 sub-teams. And the reason we were limiting this scope to consultancy companies specifically is that we wanted to get a deeper view on at least part of the problem because we only had 6 data to interview. But of course, in the future, we would like to get understanding whether these are generalizable to other kinds of companies also. So the 3 main concepts or themes were experimentation, development approach, and multidisciplinary teamwork. First of all, experimentation is really a core nature of data science projects. We do not know in Hi, there seem to be some problems with the record, so I thought that I could go on in real life. So the main concepts are experimentation, which means that when we are not really sure what's going to happen, what kind of data we are going to get, or and so on, it's easier to start experimenting something, what we are seeing, and then go on with that one. This is related also to the next concept that we have an iterative development approach, meaning exactly that the customer may not know in advance what they want, and we don't know what we can actually answer with the data. And after we have started with this proof of concepts, we often end up in like multidisciplinary teamwork, which also has software developers and maybe software engineers who have been working, who are also working on the topic, especially when taken into production, etc. So we had these 2 research questions. What is the typical process flow of a data science project? And we found out that there are similarities to software development. However, what is significantly different, or not significantly, but like from the basics, it's different, is the uncertainty. It is related to data, which is there are always something missing, something wrong with the data. And do we even have the data available? Also, it's more difficult to get the goals from the customers. So what are those, and can we answer those? Because of it may be related that customers are not so familiar with data science processes when compared to software development processes or buying software development. And the last point is that it's difficult to find when we are actually ready, when we have achieved what we're aiming for, which causes data science project easily to go on forever. Then the second question was what kind of people are part of the projects, and especially in the larger project, especially software developers and data engineers are reusable. One comment was that software developers might be like very valuable, that save days of your work very fast because they have the experience you don't have on doing stuff. Data scientists often are still quite keen on the software development side. And also the data scientists have diverse backgrounds from statistics to software developers and so on. And then to the conclusions. The first and also I think most important one is that there is still work to be done to get actually more major data science processes. We are still like decades, maybe in the process of what software development was decades ago. So even if we do have differences in data science processes, we probably should and will get practices from software development. So we are not having like a single data scientist doing stuff with a team around, but maybe somehow spread the information cross-functional teams, etc. That would be something to go on for. Then the future questions are, we have concentrated on consultants teams. Are in-house teams different? It could be assumed that they are more mature. Then the enterprise companies we considered here, small to mid-sized companies, and also how general in general how general all these we use. Outside Finland where these were done, but also in we are also preparing a survey on more general audience. So we probably have some, we'll get answers to the last one. So those were my questions. Any questions or comments on this one?
Sure. Thank you, Timo, and also thank you for being ready also to make it live. Yeah, so we have one question from Brazil, from Rafael Mayani de Melo. And he asked, what did you find addressing verification and validation activities in data science projects?
Come again, aggressive. Can you come again with the question?
Yeah, so what did you find addressing verification and validation activities in data science projects?
Yeah, it's yeah, I'm not sure. I actually checked the question because addressing verification validation. Okay, related to that one, I'm not sure what the question actually means, but what is a problem? As mentioned, I'm not sure if it was in the slides actually, but there is a problem that data science projects usually are assumed to be validated and verified. However, it often happens that actually, as mentioned, that the processes in data science projects are not supporting this easily, especially in the proof of concept phase. You are only one person is checking things, and you don't really, nobody is necessarily validating things. But later, when you are multiple people and also cross-functional, not cross-functional, but more people from different backgrounds, maybe 10. But I feel like, especially in consultants business, when you are doing things fast, that's something that we often are missing, validation verification.
Okay, so I see.
That's actually one question we are going to like stick deeper into the survey. That's a very good question.
Very good. And I guess it's also a challenge, as you said, in these multidisciplinary teams. We have more questions from the YouTube chat. So the following question is from Timo Letonen. So talking about results, what is the definition of them in a data science project?
Yeah, that's a very good question. And that's like what often happens is that if you start with the proof of concept, you have some goals to go, and you try to achieve those. And if you you don't actually in advance know what you're going to offer and what's necessarily the goal, which ends up in like going forever, maybe after different kind of goals. So, for example, if you're doing a recommendation system, you may like in the end, first phase, you are going to get some kind of recommendation system, but after that, you easily can increase the and make it better and better, understand it more and more. So that's a very good question. I think bigger question for data science projects than software development side.
Okay, so indeed it was from a colleague from Solita, Finland.
Yeah, well, my old colleague, actually.
Very good. And I'm just curious, so in your company, do you work as a software engineer or data scientist?
I'm more like big data generalist currently. So I'm working on data science, maybe architectural role more in currently. But so I'm doing also data science projects now and again.
Okay, so thank you again for your presentation. And now we can go to the following presentation of this session, which is entitled From a Data Science Driven Process to Continuous Delivery Process for Machine Learning System which will be presented by Lucy Ellen from the University of Technology, from the Chalmers University of Technology in Gothenburg, and this is a collaboration with Ericsson. Okay.
Yeah, hello. So welcome to this presentation, and my name is Lucy Allen, and I'll be presenting on behalf of my co-authors, Yvette, Eleanor, and Jan Bosch. And as a background, I think most of us already know now there's increasing interest in machine learning or AI techniques, and when developing these systems, actually, if you're coming from software engineering background, you tend to see that there's a bit of disconnect in machine learning process or machine learning workflow. And much of the research that is contributing within this field, you will see that there's a need to actually adapt some of the software engineering practices and knowledge when working with such systems. For instance, in the area of requirements, or even how do we test these systems. And so in our case, we wanted to understand what is the potential use for existing software development process, or how to best align software development process with this machine learning workflow. And we specifically looked at continuous delivery, which is a more modern approach. And how we went about exploring this was that we did a literature review, a systematic one, and we focused on grey literature, but there was, and we focused on papers that had discussed deployed machine learning systems, so experience reports and also reports that were coming from industry. So we specifically looked at for deployed systems. But then we realized in this formal academic venue, there was very little studies. So these like a starred study, which was just one. And then we thought of going more to grey literature, so doing a Google search for continuous delivery and machine learning. And also we then later realized there's increasing use of ML ops, so we included that in the study. So we went with the inclusion and exclusion, and we ended up with a couple of papers, which were 8 documents. But for this, we actually extracted the development context, but also we extracted what sort of systems were they, and also the development process and the tools that were used. And actually, in some of the papers, or the documents, they actually explain the evolution of their practices. So it was small amount of documents, but a bit richer in a sense. And for this specific paper, we looked at development practices and the infrastructure. And for the second approach, okay, from the literature, we derived a conceptual model, which I will present as part of the results. And we then wanted to initially validate this conceptual model. And we used a more like a focus group discussion. And we had 10 practitioners. So I facilitated this together with Eleanor, who is the co-author and a practitioner within the company. And we basically spoke with analytics organization within this company. And in the first part of the session, I tried to ask what is the current way of working. So we selected some use cases that these data scientists and machine learning engineers were working, and in specifically we looked at how to improve quality, cases that were focused on improving quality. And for instance, the use cases were predicting faults from hardware returned units, and also classifying faults if they were either software faults or hardware faults or no faults found. But also there was a case that they were working on. So while still in the factory, is there a way to detect that this hardware will potentially be returned? So in our analysis, we actually saw that companies don't actually just outright apply continuous delivery or these concepts within the development, but actually it comes about as a result of improving their process and also the infrastructure. And this such evolution, we mapped it into this five-staged hierarchy, and I will explain each stage. And so the first stage, we noticed that typically when experimenting or prototyping, which is often the case in many of the use cases, is that they tend to focus more on the data science process. So they would manually maybe work on data which is not representative of the current infrastructure that they have or data collection that the company has. Maybe just use a Jupyter notebook with a CSV file and trying to really derive a good model for the specific use case that they've identified. Then after a certain having a model, that's when they start to think of deploying the model, but then the things might not actually, oftentimes things might not work when deploying such model. And also these manual activities that are performed, they tend to be very error prone. And in our focus group, for instance, we noticed that the stakeholders, of course, a stakeholder had approached the data science team and asked if they could build a model for this use case. And then data scientists spent some time exploring on this use case. And then later, after 6 months, they do a demonstration and to the stakeholder, and then they decide, okay, how then can we deploy or visualize the results of our model? Then in the next stage that we observed was more like now companies then try to standardize or at least making this data science process to be more operational friendly, so like easy for them to deploy. So what comes about here is more on systematizing or instituting much of this machine learning workflow in a systematic way. So for instance, how is our data collection practices happening within our organization? Then some of the challenges, of course, you can at least be able to develop a model within that infrastructure, but then if you increase the use cases, then you need to have a capable environment where you're able to track the different experiments and the results of your model development. So this, in our case, we noticed that, of course, once they were ready to deploy, with the initial deployment, they faced a lot of challenges because some of the implementations that they were done, they were not having maybe, for instance, basic things as unit tests. But also we noticed that they were able to systematize, maybe introduce like a data ingestion or parsing within the data collection phase, and also version controlling of their basic Jupyter notebook. Then, of course, we have this automated stage where we see now companies are becoming more experienced with operationalizing machine learning, and they tend to adopt these machine learning platforms. So these are like end-to-end workflow, which is having much more automation, maybe within a step, for instance, a data collection step, but also the interconnect between different steps become more automated. And in this case, for instance, in the focus group, what we saw, in addition to having a systematized way of maybe doing ingestion and parsing from the log data that they collected, was that they considered this environment not to be sophisticated, like what's the state of the art environments like TensorFlow extended platform and maybe Kubeflow and whatnot. So they were exploring that. What we realized also within Uber's case, for instance, was that, okay, once they have, let's say, a platform like Michelangelo, which is a machine learning platform from Uber, they used some components of this, but then they extended these components to also include, in the case of autonomous driving case at Uber, to extend this with system-wide tests. So they had system-wide metrics that were more focused on safety, for instance, and comfort metrics, in addition to model accuracy. And also, eventually, they were also able to do hardware tests. So there's a more consideration for quality assurance in the system-wide, in addition to just focusing on the model metrics. And in our case, for the focus group, we noticed that the data scientists had a boot camp for how to implement unit tests, and they were already adapting a continuous integration environment and specifying tests for their development infrastructure. But of course, there was no yet feedback loop from monitoring of the models in production, such that you can trigger the retraining. So what we also saw, which was coming from, again, Uber here, is that once you have a unit test and your system-wide tests together with your efficient model development platform, there tends to be a orchestration service that tries to trigger the different steps depending on the new data that is being monitored and coming in. So they used, for instance, in their case, Jenkins, because they had this versioning of the different artifacts, and also they mapped the different dependencies within the different components for these different model artifacts, and they could orchestrate using Jenkins the whole training pipeline. So in conclusion, we actually explored the incorporation or the alignment of machine learning workflow together with existing software development process, continuous delivery specifically, and we looked at great literature with one paper from academic formal literature, and derived a conceptual model, and we provided an initial validation of this model, and hope that other studies in the future would contribute to evolution of this model. Thank you.
Okay, so thank you, Lucy Ellen, for the presentation. So a couple of questions. The first one would be, how many primary documents did you consider in your gray literature review?
So they were actually 8 altogether, with one from formal literature. So in our list here, these are the references, the ones I'm sharing, and the one with the starred is the one that came from a formal literature, and I think it was speaking of agile practices.
Okay, and then you mentioned, for instance, an example of Uber in the last, let's say, the most advanced level or maturity level of your hierarchy, automated and fully integrated.
Yeah.
Was the case of another of the studies, or what was the next primary document or the next company that reached a high level in your hierarchy?
I think the problem is Uber was explicit about it. I'm sure the other companies also must have reached this stage. The only problem is they were not explicit, so they could speak. Even Google has had actually a step that related to continuous delivery. I think there was a reference from Google with that. So for me, it's these companies that we presented from the literature. Most of them had already started to do this, because that's the search term we were actually using from this literature as well. So almost all of them, I would say.
Okay.
But
and how much? When did you consider to include a primary document that they really are developing and evolving an ML
they
system?
need to have experience with deploying a model, and then with the affiliation, we checked the affiliations, who's authoring this paper, with what affiliation are they, and how exhaustive, because they would actually point to several other documents which are supporting current explanation of things. So if I could look at maybe Uber, for instance, there, which was published actually within their R&D engineering blog, I could trace a couple of documents that they were also explaining further. So I needed to spend time to ensure that these reports actually have this traceability, which meant that maybe they could send me to a YouTube presentation and also other documents that are published within their forums.
Okay, so thank you again for your presentation. And now we can see the last presentation of the first day of the conference, which is an end-to-end framework for productive use of machine learning in software analytics and business intelligence solutions, which will be presented by Iris Figarist from Siemens in Munich.
Yes, hi, thank you for the introduction. Hi everyone, my name is Iris. Today I'm going to present our paper, an end-to-end framework for productive use of machine learning in software analytics and business intelligence solutions. Before I go into the details of our study, I would like to provide a little bit of background information. So I think everyone is aware of the hype around artificial intelligence and machine learning these days. And it's already being used in a wide range of areas, also including software analytics and business intelligence. And now oftentimes software providers start implementing custom software analytics and business intelligence solutions just to reach the desired depth of information. But when it then comes to deploying or productizing the analysis, they often run into a couple of challenges. So for example, there's often a lack of priority time and resources assigned to set up and maintain ML-based solutions because the managers often do not perceive that as something of direct customer value. And next, the effort of getting out of the prototypical stage and deploying and maintaining the ML models is perceived as very high. And also in early phases, the work is often done by team members who are just convinced of the value of these solutions. But that also means that there's usually a lack of expertise, since the product itself is usually not related to machine learning at all. So now all these factors result in the challenge of these solutions not being deployed in production. So the goal of our study was to develop a framework that guides and supports practitioners in productively applying the machine learning models to software engineering data. Now, in order to achieve this, we conducted a literature review of important domains related to machine learning, so specifically data management and processing, model building, and model deployment. We then derive a framework for building an end-to-end machine learning-based software analytics and business intelligence solution. And in the last step, we validate the applicability of the framework by comparing it to the current state of a custom software analytics solution and using the framework to strategically plan and direct the upcoming activities. Now let's take a first look at the results of the literature review. So in total, we have identified 19 different activities that are commonly part of data management and processing in the literature. We were able to group these 19 activities into 6 categories. For time reasons, I'm only presenting a small subset of these activities in this talk, but if you're interested in the others as well, you can of course just take a look at the paper. So the first category is called data preparation, during which the raw data is examined and transformed for further usage. Next, there's data cleaning, during which the quality of the data is assessed and improved. During data validation and evaluation, you basically make sure that the data makes sense and that you, for example, evaluate the choice of the input features you made. And during data serving, newly emerging input data needs to be converted to so-called serving data, which can be processed by the model. And then lastly, you have to set up extract, transform, and load jobs in order to have a continuous data extraction and processing. Now for the model building, we have identified 3 categories in the literature, which are model preparation, the actual model building, and model evaluation. During model preparation, you consider the type of data that you have and the goal that you want to achieve. And based on this, you select appropriate model types and do some feature selection and so on. In the model building phase, you build the actual model. So by, for example, training the model using your training data and then applying it to the test data. And in the last step, you then have to evaluate the model and its performance. Lastly, let's now take a look at the model deployment and serving phase. So we have again identified 3 different categories. First, you need to have several components in place that can be automated to perform certain tasks. So for example, a continuous model evaluation and monitoring. Then you also need to set up a couple of things, for example, the model lifecycle management. And then in the process category, you have the actual activities. So for example, loading the model before unloading an old one, applying the model to new serving data, evaluating its performance, and so on. And now, based on the results of this literature review, we have structured all the activities to develop a generic framework on which we are now going to take a look at. So the entry point of our framework is raw input data from multiple sources. And what we have observed in the literature and also from experience is that people usually start out with implementing a prototype. And this is also why we introduced this prototype cycle in our framework. So you first need to extract and store the data in a useful way. And then the prototyping cycle basically comprises most of the activities that we have identified for data management and processing and for model building. And it's very important to note here that this is an iterative approach, and it can take multiple iterations until the right data format, input features, model types, or model parameter settings have been identified. But then once you have a final model that you want to deploy, you enter the so-called deployment cycle. And in order to get there, you first need to set up ETL jobs that automatically handle the data extraction and processing. Then you load and validate the model before deploying it in production. And then for each new batch of data, a validation pipeline needs to be triggered before it is then transformed to serving input data that can be processed by the model. And you also need to set up the components for continuous model and data evaluation, and the results should be visualized. And then, in case there were no errors, the serving data should be stored as training data. The magnifying glasses indicate checkpoints that basically mean that you have to continuously check and monitor whether all the components you have set up and automated are running correctly. And now, after several iterations or a certain amount of time, you might notice that the model does not perform as desired anymore, which means that a retraining of the model should be triggered. So you enter the so-called update cycle. In the update cycle, you generate new data sets for training that now include the recently processed serving data, or if required, also other changes, of course. And then a new model is trained and evaluated, also in an iterative approach similar to the prototyping cycle. And once a new version of the model has been accepted, it is added to the model management, which gives an overview of all deployed models. And it's also useful in case you need to do a rollback. And then the new model is deployed to production. Now, to validate the applicability of our framework, we compared the activities to the activities we had executed during the implementation of a custom software analytics solution project for an industrial platform provider. We have worked with 2 software architects and 2 product managers on this project, and the product managers, who are also the future users of the system, requested a customer churn analysis. So they wanted to know which customers are not going to prolong their subscriptions based on their product usage. And since the product itself is based on AWS, we decided to use all the available AWS services for our implementations as well. So we first extracted the raw data from the multiple data sources, and we set up a pipeline for extraction, preparation, and storage in AWS 3 buckets, which offers a REST interface that allows us to pre-process and analyze the data in AWS SageMaker. Now, in the table on the right, you can see the label and all the input features we use to train the prediction model. So, for example, the daily active users, the requests per user and day, or the request and response sizes, and so on. And we then experimented with various classifiers and evaluated their performances on the test sets, which you can see in the table on the lower left. After we were happy with the model's performance, we then decided to actually deploy it. So in a first step, we set up ETL jobs that are extracting the data and doing the pre-processing and so on. And the software architects also set up checks that make sure everything is running correctly. We then deployed our model to production, which you can see on the right. And we then visualized the results using Amazon QuickSight, which you can see on the lower left in a dashboard. And yeah, so this is basically what the initial solution looks like. And in our next step, we now use the framework to plan our upcoming activities and also identify missing activities or components. So for one, we noticed that the storing infrastructure was not yet complete. So we needed to add an additional S3 bucket for the serving data. And also we had to add new pipelines for transferring the data between the serving bucket and the training bucket after that batch of data has been processed. And we also didn't have a model monitoring in place yet. So the next steps now also include setting that up. And at this point in time, we did not have to retrain the model yet. So we are still kind of evaluating at what point this should happen. And in order to do this, we still need to set up a model management for that and look into an SDK for a SageMaker that allows us to automate the retraining and deployment. Now, to conclude, we can say that the activities that we have identified in the literature are consistent with the activities we had to perform for successfully implementing our prototype, setting up continuous data extraction, processing, and validation pipelines, and deploying our model. The framework supported us in keeping an overview of the remaining tasks, and also by following the cycles and activities in the framework, the definition of the roadmap and next steps was kind of efficient and easy for us, and we were able to quickly identify errors or missing components in our original approach. This is the end of my presentation today. Thank you for your attention, and I'll be happy to now answer any questions you might have.
Okay, thank you, Iris, for the presentation. So a couple of questions while we wait for more questions through the YouTube chat. So the first one would be, you mentioned you had a few models that you deployed once you were happy about them. So how did you validate these models? Why were you happy about these models?
Well, we basically used the standard performance measures you have in data science or machine learning. So accuracy scores, loss, F1 score, precision recall, and that it was a standard classification problem. So that made it, kind of easy to know when you're happy or not.
Okay. And then the second question would be, okay, so this was done in the context of software analytics. So you show in one of the slides some of the target and input values of these prediction models. So what was your data mining goal, or what is what you wanted to do with respect to software analytics and the benefit for this company where you made where you applied this whole pipeline?
Yes, so we have worked with, as I said, an industrial platform provider, and the product managers of that specific platform wanted to know why customers are leaving the platform, and they wanted to predict the customers that are going to leave the platform, just in order to being able to reach out to them beforehand and maybe convince them to stay. So the label we used for our prediction model was basically churn or non-churn. So we looked at the historic data and kind of knew which customers had already left the platform and which stayed. And then as input features, we used different usage metrics of these customers. So for example, the number of users, the number of requests, the request types, the response sizes, the request sizes. And based on that usage, we then trained a prediction model to predict whether a customer is going to continue subscription or not.
Okay, so these results were used in deployment in your company, the results of your whole pipeline?
Yes, yeah.
Okay.
Well, we're still in the deployment cycle, so, but yes.
Okay, so thank you again for the presentation. Okay, we have one more question here.
Okay.
From Andreas Jedriska. So is Chris DM, in Chris DM, sorry, there is a business understanding that is used to find a relevant question, but also for the evaluation in the end with respect to, for instance, the usefulness of the results. Was it in your cycles?
To evaluate the usefulness of results?
Yeah, so a couple of things, the business understanding and the evaluation of the usefulness of the results. Yeah.
Yes, so I think it's not explicitly stated in the cycle, but we have very closely collaborated with the technical stakeholders as well as the business stakeholders. So I think the business understanding was there just by having all these interview sessions we did with the product managers. Mm-hmm. And we, of course, also had several feedback iterations to evaluate the usefulness of results, and also to take a look at the dashboards and ask them whether it helped them or not. So that was kind of in there, but it's not explicitly stated in the cycle. That's right.
Okay. So thank you again for the presentation and questions. So this is finishing the third session of the conference. So thank you to all of you who attended today. And just a reminder, tomorrow we will have the second day of the conference. So we have 3 more sessions, the same as today. And the topics will be on Agile, social and human aspects, and development practices. And furthermore, at the very end, we will have a closing session. So hope to see you tomorrow. You have the link on the PROFES2020 website for tomorrow's session. So see you and hope you enjoy. Bye.